This is Apollo Control at 176 hours 20 minutes. We've had no further conversations with Apollo 12 since Don Lynn, the Capcom, said goodnight to them an hour ago. At present, Apollo 12 is 10,111 nautical miles from the moon. Its velocity 4,250 feet per second. All systems that we are monitoring here during this sleep period continuing to function normally. We do not have the biomedical instrumentation on any of the crew for this sleep period. This is Mission Control Houston at 176 hours 21 minutes. This is Apollo Control at 177 hours 25 minutes. Apollo 12 now 12,759 nautical miles from the moon, speeding home at a velocity of 4,132 feet per second. We still have had no conversation with the crew since an elapsed time of 175 hours 20 minutes when we said goodnight to them. We are continuing to monitor systems by telemetry. Performance is normal. At 177 hours 26 minutes, this is Mission Control Houston. This is Apollo Control at 177 hours 49 minutes. The change of shift news conference in the Houston News Center will begin at 8:30 p.m. Central Standard Time, 8:30 p.m. Jerry Griffin and the Gold Team is being relieved now by Flight Director Clifford Charlesworth and the Green Team. Capcom coming on shift now is Paul Weitz. Apollo 12's distance from the moon at present is 13,732 nautical miles. Velocity 4,098 feet per second. This is Mission Control Houston at 177 hours 49 minutes.
This is Apollo Control, 179 hours, 22 minutes, ground elapsed time. Some 64 hours, 59 minutes until entry. Apollo 12, crew still asleep at this time. Now, some 17,405 nautical miles out from the moon, traveling at a velocity of 4,003 feet per second. Relative to the moon. Spacecraft weight 25,175 pounds. Crew is, according to this flight plan, scheduled to be wakened at 2:30 in the morning Central Time. However, it's planned to let them sleep as long as they want to, and they in turn would make the first call back to Mission Control. At 179 hours 23 minutes ground elapsed time, this is Apollo Control. This is Apollo Control, 181 hours 8 minutes ground elapsed time. Apollo 12 spacecraft homeward bound, some 21,524 nautical miles out from the moon, velocity 3,933 feet per second. Countdown clock to entry interface are 400,000 feet above the surface of the Earth, now showing 63 hours 12 minutes until entry. Crew still asleep at this time. It's a situation where don't call us, we'll call you. The crew will sleep longer than the scheduled time in the flight plan. And at 181 hours, 8 minutes, ground elapsed time, this is Apollo Control. This is Apollo Control, 182 hours, 21 minutes, ground elapsed time, 61 hours, 59 minutes until entry interface, Monday afternoon. Distance now from the moon of Apollo 12, 24,356 nautical miles. Velocity, reference to the moon, 3,899 feet per second. Crew still asleep at this time. And at 182 hours, 22 minutes, ground elapsed time, this is Apollo Control. This is Apollo Control, 183 hours, 30 minutes, ground elapsed time, 60 hours, 51 minutes until entry interface. Crew of Apollo 12 still asleep at this time. Spacecraft Apollo 12, meanwhile, is now 26,984 nautical miles out from the moon on the return leg home. Velocity relative to the moon, 3,874 feet per second. Some other numbers for those who like to dabble in statistics. Apollo 12 will cross over from the moon sphere of influence to the Earth sphere of influence at a ground elapsed time of 186 hours, 30 minutes, 43 seconds. The equal distance point halfway between the moon and Earth will come at 219 hours, 47 minutes, and 40 seconds. The distance at that time will be 110,904 nautical miles. The point of equal velocity between Earth and Moon, that is, when the spacecraft velocity relative to both bodies is equal, will come at 207 hours, 14 minutes, 40 seconds. The velocity at that time will be 3,919.5 feet per second. The midpoint, or halfway back between TEI, Trans-Earrh injection, and entry, will come at a ground elapsed time of 208 hours, 23 minutes, 41 seconds, at which time the spacecraft will be 139,992 nautical miles out from Earth. Velocity relative to the Earth, 3,991 feet per second. And the moon figures at this halfway point, 83,322 nautical miles out from the moon. Velocity 3,944 feet per second. And at 183 hours, 32 minutes, ground elapsed time, this is Apollo Control. This is Apollo Control, 186 hours, 7 minutes, ground elapsed time, 58 hours, 14 minutes until entry interface. Still reference to the moon in velocity and distance. Apollo 12 is now 32,932 miles outbound from the moon, traveling at a velocity 3,834 feet per second. The orange team of flight controllers, headed up by Pete Frank, is taking over here in the control room from the green team, Cliff Charlesworth. It's been a rather quiet night. The crew is still asleep. No estimate yet on when they will wake up, begin the day's activities. Planning for mid-course correction burn number 5 is being slipped hour by hour. It'll be a rather small burn in any case. 186 hours, 8 minutes ground elapsed time. This is Apollo Control.
This is Apollo Control Houston at 186 hours, 25 minutes now into the flight of Apollo 12. Pete Frank's team of Orange flight controllers are now aboard in the Mission Control Center. Our new capsule communicator for this shift is astronaut Ed Gibson, replacing Paul Weitz at that position. Presently, Flight Director Pete Frank is going around the room discussing those items that should be accomplished once the crew is awakened. We are presently still looking at the performance of a mid-course correction 5. This would be a relatively slight correction using the RCS. Although a pad is now being updated, we would be looking at a delta V in the order of 2.2 feet per second. Without a mid-course at this time, we show an entry angle at entry interface of on the order of 7.95 degrees. The optimum number we're looking at there is 6.5. The Apollo 12 spacecraft at this time is in a relatively insensitive part of the trajectory, and it's, as far as the performance of MCC-5, it's very much independent of where it's done, as long as it's done on the order of ground elapsed time 186 to 187 hours. We will pass along the pad numbers as soon as they're worked up in final form by retro and the flight dynamics officers. In opening his comments, Pete Frank at this early hour of the morning said perhaps we should open with calisthenics. He down in the trench. This caused a few heads to bob up, and he stated, "Everybody looks bright-eyed, but I don't see any bushy tails." We're currently looking at sphere exit, or the exit from the lunar sphere of influence in the order of ground elapsed time 186 hours, 30 minutes, 43 seconds, some less than 3 minutes from this time. We presently show a velocity on Apollo 12 en route back from the moon of 3,830 feet per second, an altitude from the surface of the moon of 33,732 nautical miles. So at 186 hours, 29 minutes into the flight, this is Apollo Control Houston, continuing to monitor. This is Apollo Control Houston at 186 hours, 34 minutes now into the flight of Apollo 12. The Apollo 12 crew still in their rest period. Meanwhile, in Mission Control Center, looking at our digital displays, we have changed the reference from Moon to Earth reference. At the present time, we show Apollo 12 at an altitude of 183,308.1 nautical miles above the Earth. The spacecraft's velocity relative to Earth now reads 2,972.9 feet per second. This is Apollo Control, Houston. This is Apollo Control, Houston, at 187 hours, 10 minutes now into the flight of Apollo 12. We've still had no contact with the Apollo 12 crew, apparently continuing in their cycle of rest. However, in Mission Control Center, we've worked up at the retro fire officer down in the front row has worked up at least a tentative pad for mid-course correction number 5. Assuming that this pad is enacted, we would have the ignition of MCC-5 at a ground elapsed time of 188 hours, 27 minutes, 14 seconds, with a delta V of 2.2 feet per second. Its effect would be to modestly shallow out the trajectory. On its present course, Apollo 12 would be looking at an entry angle of minus 7.95 degrees. The effect of this slight burn would be to bring the entry angle down to minus 6.5 degrees. Also, it would have an effect of slowing our arrival time at entry interface to about 1 minute. On its present course, Apollo 12 would arrive at entry interface at 244 hours, 21 minutes, 4 seconds. With this slight alteration, the GET time should be 244 hours, 22 minutes, 5 seconds. We'll stand by and continue to monitor. We presently show a ground elapsed time into the mission of 187 hours and 12 minutes. This is Apollo Control, Houston. This is Apollo Control, Houston, at 187 hours at 25 minutes now into the flight. Apollo 12 presently traveling at a velocity of 3,000.4 feet per second. Its present altitude above Earth, 181,838.7 nautical miles. Looking at our displays in Mission Control Center, there is some indication that the crew may be awake now. There's been some activity reported on their display keyboard for the guidance computer. And we would expect capsule communicator Ed Gibson will be in touch with Apollo 12 before too very long. We're at 187 hours, 26 minutes into the flight and continuing to monitor.
With both feet on the ground. 12, welcome back to Trans-Earrh Coast.
Good morning, Houston. How are you?
Very good. How are you folks?
Fine. We'd like to say we really sacked out last night, I guess.
That you did. You had to. Paul Weitz was on.
Very good.
Say, Pete, right now...
What's new in the world of news today?
Okay, why don't we first figure out how you want to go from here. We could take and pick up mid-course 5, which is relatively small, a little over 2 feet per second at 188.27, or we could slip it a little bit. It's maybe up to on the hour even. It's really up to you folks.
188.27, huh?
That's right. It depends upon how far you are along in your post-sleep activities. It can be slipped just as easily.
Okay, why don't we go ahead and burn it on time? I'll tell you what, the only thing we have to do is change the canister. And we all had 12 hours sleep last night, I think. I lost track of time there. And the PRDs are 11026, 11025, and 04027. And we'll go ahead and do a quick P52 here for you, the PTC orientation. And then give you the confuser, okay? And you can uplink the load. Is that what you want to do?
Okay, that sounds good.
And in the meantime, we'll go ahead and put on... what do you want us to try and get the H2 purge done? And the wastewater dump before, and the fuel cells before we disburn?
Yeah, let's go ahead and try to carry things out in the same order in which you would have done them before. That is, all flight plan items preceding your mid-course 5 were still required, and accomplish at your own crew-determined pace. Your water dump and fuel cell purges after your sextant star check.
Okay, very good. We'll go ahead and do the P52 right now.
Okay, and one word on after MCC5 and your associated data dump. You roll the spacecraft 180 degrees and hold attitude rather than PTC for the next 1.5 hours, and then you perform P23 nominally scheduled for 189.
Okay, P23 for 189. What roll orientation did you want?
Okay, you'd be rolling 180 degrees from the attitude you'd have in MCC5.
Okay, very good.
We have a consumables pad for you here, and we'll be coming up with a maneuver pad shortly.
This is Apollo Control, Houston, at 187 hours, 48 minutes into the flight. That was Pete Conrad talking to Capcom Ed Gibson, and as you heard, we commenced with our wake-up music about 5 minutes ago. And it became a bit of a battle of the bands as the crew played back music to the ground from their onboard recorder. We presently show Apollo 12 traveling at a speed of 3,013.5 feet per second and at a distance from Earth of 181,157.7 nautical miles. This is Apollo Control, Houston.
Apollo 12, Omni Charlie. Omni Charlie. Apollo 12, Omni Charlie, Omni Charlie. Apollo 12, Omni Charlie, Omni Charlie. Apollo 12, Omni Charlie, Omni Charlie. Apollo 12, Houston.
Okay, here's the alignment for you. It was done on 6 and 45. Star angle difference 4 balls 1 plus 00288 minus 00301 plus 00211 1875445. And the computer is yours.
Roger, Pete. You can go ahead and cut off the cryo fans.
Okay.
And we have a maneuver pad and consumables update in that order when you're ready to copy.
Okay, give me the consumables update first.
Okay. GET 18730. RCS total 34. And Alpha through Delta 35, 32, 34, 34. H2 34.5 and 34.5. O2 37.3, 40.2.
Okay, I copied all that and we're ready for the maneuver pad.
MCC5 RCS GNN 25138. Your trims are NA. GET 188271374 plus 00020 and Delta VY, Delta VZ are 0. 089er 339er 007 noun 44 NA 00020 005 00020 22 3230.
Hold on a second.
Roger.
I understand now. The Delta VT was the 00020. Start from there.
Okay. First noun 44 was NA, Delta VT was 00020, 005, 00020, and that was Delta VC. 22 3230 359. Foresight star 016. Up 072. Left 42. Noun 61. Minus 1581. Minus 16514. 11711. 36198. 244 2234. Under comments, your SARS, Sirius, and Rigel. Alignments 256 152 069. The ullage is a 4-jet RCS plus X.
Okay, RCS GNN 25138, NA 188271374 plus 00020. Next two are zips. And then the roll is 089339 NA 00020 005 00020 223230 359 016 up 00020 1, minus 16518, 11711, 36198, 244 2234, zeros in Rigel, 256 152 069, 4 jet plus X.
Okay, noun 61. Longitude was 16514, and the other is correct.
Roger, I've got minus 16514. Is that right?
That's Charlie.
Okay. Houston, also we're going to vent the battery compartment there. That's up to about 3.6. We'll do that along with the rest of the dump.
Roger.
It's Apollo Control Houston at 188 hours, 1 minute in the flight. That was Al Bean taking down the mid-course correction number 5 maneuver pad. We're looking at GET of ignition, 188 hours, 27 minutes, 13.74 seconds, with a total delta V of 2 feet per second.
12, the computer is yours.
Roger.
We presently show Apollo 12 at 180,772 nautical miles away from Earth, now traveling at a velocity of 3,021.2 feet per second.
Apollo 12, Omni Bravo. Apollo 12, Omni Bravo. Apollo 12, Omni Bravo. Apollo 12, Omni Alpha. Omni Alpha. Apollo 12, Omni Alpha. Omni Alpha. Apollo 12, Omni Alpha. Omni Alpha. Apollo 12, Houston. Apollo 12, Houston.
Roger, Houston, we got you on the high gain now, and the H2O2 fuel cell purge is in work. The wastewater dump section will start check okay.
Roger. Apollo 12, Houston, you can hold off on that battery B charge until tomorrow.
Okay.
It's Apollo Control Houston at 188 hours, 23 minutes now into the flight of Apollo 12. The Apollo 12 spacecraft currently traveling at a speed of 3,033.2 feet per second and is presently 180,151 nautical miles away from Earth. We're 4 minutes away from MCC ignition.
Done by burn time. What would you like us to do about that? We can purge oxygen a minute 20 for each, or we can do something else.
Stand by, Pete. Apollo 12, Houston, you can go ahead and continue on with the purge through the burn.
Okay.
We're 30 seconds away from ignition for MCC 5. Ten seconds away now. GNC reports plus X. We'll stand by for a burn status from Apollo 12.
Houston, the burn's complete.
Roger, 12.
The residuals were 0.
Roger.
That was Pete Conrad reporting the burn completed with 0 residuals. We're at 188 hours, 28 minutes into the flight, and Apollo 12 now 179,992 nautical miles out from Earth.
For your information, this EMS is useless for this kind of thing. I finished the burn, I was reading 1.8 feet per second. It's got a pretty sizable bias on it. And I have reported this before because it has been working and meeting all tolerances. But in the EM delta V test, it goes down to minus 18.1, and it's been consistent that way throughout the flight.
Roger, Dick. 12, Houston.
Go ahead.
You enable AC roll in the DAP, and also we're showing that your weight is about 400 pounds heavier than what we passed you in the pad.
Okay, now Houston, you want us to roll 180?
Stand by for just a moment, Pete.
We're rolling.
Pete, if you've already eaten, you can go right on to the P-23s, and the attitude for those are in the flight plan, and they're good.
Okay.
It's Apollo Control, Houston. The P-23 reference there is computer program 23, Cislunar mid-course navigation. We now show Apollo 12 at 179,851 nautical miles away from Earth, traveling at a speed of 3,039.6 feet per second. We're at 188 hours, 34 minutes into the flight of Apollo 12, and this is Apollo Control, Houston.
Hey, Apollo 12.
12, Houston, go ahead.
Roger, for these P-23s, I'm going to disable 2 quads in the DAP. Which 2 do you suggest?
Alpha and Bravo. Disable Alpha and Bravo.
Roger, Alpha Bravo, disable.
And 12, you can give us Omni Alpha as you approach the high gain limits.
Roger, Omni Alpha. Omni Alpha.
This is Apollo Control, Houston, at 188 hours, 52 minutes now into the flight of Apollo 12. Apollo 12 now traveling at 3,050.7 feet per second. Its present distance away from Earth now 179,280 nautical miles. We've not been in contact with the Apollo 12 spacecraft for several minutes. The Apollo 12 crew now making preparations for cislunar navigation tasks. However, our earlier contact with Pete Conrad and Al Bean, specifically, they've sounded fresh and chipper. Each reported approximately 12 hours of sleep, giving a combined total of 36 hours, probably some kind of record for sleep in spaceflight. We're at 188 hours, 54 minutes into the flight, and we will continue to monitor the air-ground loop.
Apollo 12, Houston. Apollo 12, Houston. Apollo 12, Houston, Omni Delta. Omni Delta.
Roger, roger. How's Omni Delta, Houston?
Roger, thank you, Pete. Say, do you have a reason for not selecting balanced couples for P23? Hello, 12, Houston.
Go ahead, Houston.
12, do you have a reason for not selecting balanced couples for the P23?
Do you read the CMP, Houston?
That's negative, Pete. We're not picking up the CMP at all. The only transmissions we've heard are from you.
Okay, I got him. How about now?
Okay, Dick, you're coming in now. Okay, Dick, we got you. Go ahead.
I have a reason for not using... Yeah, I sure have a reason for not using balanced couple, and that's when I'm using the minimum impulse controller in the LEV. This balanced couple on, the vehicle is far too sensitive to get decent marks with this thing. The vehicle motions are too exaggerated. My P23 information will be much better if I use unbalanced couple.
Okay, Pete, or Dick, good idea. Thank you. Hello, Pete, Houston.
Go ahead, Houston.
You gave us a battery manifold pressure of 3.6. Would you confirm that that is volts?
Yeah, well, I read it wrong. I was looking at the wrong thing. It was 1.8 volts.
Raj, 1.8. We did a little head scratching down here on that one. Thank you.
All right, sorry.
No problem. It's good to exercise the system. Apollo 12, Houston, high gain antenna angles for your next P23 attitude. Pitch, -55, yaw, 3.
Roger, Houston.
It's Apollo Control, Houston. We're at 189 hours, 15 minutes now into the flight. At the present time, Command Module Pilot Dick Gordon exercising the onboard navigation system, going through a series of Program 23 Cislunar navigational checks with star sightings. We presently show Apollo 12, 178,606 nautical miles away from Earth. Its velocity reading 3,064.4 feet per second. We're at 189 hours, 16 minutes, and continuing to monitor. This is Apollo Control, Houston.
Houston, 12.
12 Houston, go ahead.
Okay, I got a question for you.
Go ahead.
Anybody got any suggestions down there on how we can warm up the cabin a little bit? It's getting a little cool in here. Can we go do like we do on launch day or whatever it is, and maybe run a secondary loop without any coolant on it or something to get some heat in here?
Stand by, Pete.
Houston, 12.
12, go ahead.
Roger. How many marks second star? I've lost count. Is that 2 or 3? I believe it was 3.
Stand by, Dick.
And also ask if they want another trunnion bias before I finish off this set. Dad, you still with me?
Yeah, we're still with you. Right now, they're still scratching their head. Just a minute, Dick.
Well, tell them to quit scratching. I'll say that was 3, and I'll press on and I'll do another trunnion bias. They don't have to worry about it.
Okay, Dick, we concur.
So,
down here was that we didn't have data when you were taking your first mark, so we really weren't sure where you stood in the total flow.
That's our fault, Houston. We're good. Ed, does that mean you want me to do that first set of stars over again?
Negative on that. We got it recorded, and we'll have it dumped and take a look at it.
Okay, thank you. I'm going to do another trunnion bias and press on to star number 3.
Okay, Dick. Very good.
so Apollo Control Houston, 189 hours, 39 minutes down to the flight. That conversation with Dick Gordon, who is going through his star sighting navigation program, coming up on his third star. Apollo 12 now 177,917.5 nautical miles away from Earth, and traveling at a speed of 3,078.4 feet per second. This is Apollo Control Houston.
Apollo 12 Houston, for your calibration attitude, give us Omni Delta.
Roger, going Omni Delta.
Houston.
Go ahead.
We have a procedure here for warming up the cabin. Okay, take the glycol evap temperature in to manual and adjust the primary glycol evap in valve to obtain a temperature of the glycol evaporator out of 55 degrees.
Okay, glycol in valve to manual and adjust the glycol temp in at 55. Thank you. And be advised we're running one cabin fan right now.
Roger. Pete, on that last procedure, we want to adjust the evap temperature out to 55 degrees.
Right, temp out, as I say, temp in.
It's Apollo Control, Houston, 189 hours, 46 minutes now into the flight. That was Capcom Ed Gibson passing along procedures for warming the cabin slightly. Somewhat earlier, Pete Conrad had reported to Mission Control, Houston, that it was a little chilly inside Apollo 12 this morning. We're at 189 hours, 46 minutes, and we presently show on our displays that Apollo 12 is 177,697 nautical miles away from Earth and traveling at a velocity of 3,082.9 feet per second. This is Apollo Control, Houston.
Apollo 12, Houston, do you still have the high gain angles for the P-23 attitude?
Yeah, I think I have them here in REACT. Say them again.
Roger, that's pitch minus 55, yaw 3.
Yeah, we got it.
Thank you.
Houston 12 on the high gain back in P-23 attitude.
Roger, Pete, we've got you loud and clear.
Say, Ed, you're getting pretty doggone good at this Capcom, aren't you?
Oh, I enjoy it. Getting a little practice on these coast periods. Like I say, however, Paul Weitz is a real sleep expert.
I kind of figured last night we must have gone through 2 Capcoms in sleep.
Yeah, you went through a few. Paul Weitz came in here and was waiting 6.5 hours for the big moment, and then he overslept, and he went out of here with a long face again. However, he's on for your entry. He's assuming you're not going to be sleeping through that.
I don't think we will be. Who's the flight director down there today, right now?
We've got Pete Frank.
Oh, I thought if it was Jerry, I'd let him listen to some of my music.
Apollo Control, Houston, 189 hours, 56 minutes. That was a rather casual exchange between spacecraft commander Pete Conrad and capsule communicator Ed Gibson. You heard the reference to the sleep. Pete remarked, considering the amount of time they slept, he thought perhaps they had slept through at least 10 Capcoms. As you'll recall, they reported earlier some 12 hours of sleep apiece. We presently show Apollo 12 at 177,392.9 nautical miles from Earth, now traveling at 3,089 feet per second. This is Apollo Control, Houston.
Hey, here's Apollo 12.
12, Houston, go ahead.
Roger, have you been looking at this P-23 on this one?
That's affirmative, and we copy your optics trail light.
Optics has got me. Yeah, any suggestions? I've gone back to 0 optics.
Yeah, stand by, Dick, and we'll be right with you.
Okay.
Dick, would you take the optic switch to 0 and wait 30 seconds?
How's it look, Ed?
Stand by, Dick. We're still looking at it. Dick, could you give us poo?
Okay, you got it.
Dick, we like to sit here and poo for about 5 minutes. Maybe a possible software problem.
Okay, Ed, no problem. You've already got us thinking how to do realignments.
Roger.
Yeah, it's about time Tim got back in the game again.
Pete, you were way down in the noise level there. Would you say again?
I don't think you want to hear it.
Sounded too good to miss.
I just said that it sounds like Sim is getting back in the game again.
That's right, he's been itching to go since launch.
I'll bet he has. Since after launch, huh?
That's right, about a minute after launch.
Hey, how about looking on the records down there and find out how long it was from the time that our fuel cells dropped off the line till we put it back on? Can you do that?
Roger, sure will. 12, I can read up to you a portion of our news broadcast we were going to bring up to you a little bit later on, which is on that subject. And it was a tentative analysis shows that the Apollo 12 was struck twice by lightning during liftoff. Don Arabian told a press conference gathering in Building 1 that the strike occurred at 36 seconds after liftoff and again at 52 seconds after the Saturn left the pad. According to Arabian, the rocket and the engine plume exhaust acted just like a wire that ran from the clouds to the ground and then from cloud to cloud. There are photographs available of the strike. The Arabian analysis is called a very interim kind of report.
Hey, that's great. We're sure looking forward to seeing those films. We saw it from inside, but we sure like to see it from outside the next time. Dear said it.
How did it look visually from the LEM, looking at the command module, service module interface?
Well, we've been discussing that subject, and I guess you ought to go look at some photographs of CSMs that have had lamps on the nose and make sure that it's not from lamp thrust firing, but that junction box where all the cabling runs from the command module to the service module was black on top like it was burned. And however, I noticed on the top of the quad boxes on the service module some similar type marks. We were discussing it here, and our suspicion was possibly the lightning strikes always go to the small point, and we were suspecting, and I'm sure you have it from the outside pictures, that we probably got struck on the tower and it just went all the way down the stack.
Roger, Pete.
I wonder if they're going to revise the weather rules for launch.
I guess they're looking at it. What's been said so far, under identical conditions with an identical spacecraft, you wouldn't do it over again.
These three guys, what? Yeah, you left out one item, the crew. I guess we hold the world's record now as the world's fastest lightning rod.
The world's tallest.
Apollo Control, Houston, that was Pete Conrad saying, I guess we hold the world's record now as the world's fastest lightning rod. Ed Gibson, capsule communicator, rejoined it with, and the world's tallest. We're at 90 hours, 14 minutes into the flight, presently showing an altitude above the Earth of 176,854 nautical miles for Apollo 12, and with a velocity of 3,100 feet per second.
Hello, Al, Houston.
Go ahead.
Okay, on your request before, we showed that at 36 seconds, the 3 fuel cells went off. At 1 plus 4, 2 fuel cells were online, and at 1 plus 7, 0. Or, I'm sorry, that's 142 seconds, 2 fuel cells were online, and at 170 seconds, the third one came on.
Okay, we've been trying to remember it ever since launch. We hadn't been giving it a lot of thought since we left Earth orbit, but we were trying to think about it right now. We couldn't remember where we got it back on.
Roger. Did they indicate barber pole after that 36 seconds?
Oh yeah, they indicated barber. All 6 of them, barber pole and fuel cell 1, 2, 3 light were on, and AC bus 1 and 2 light were on, and AC bus 1 and 2 overload were on, and fuel cell bus disconnect was on, and main bus A undervolt, main bus B undervolt, and every one of those things were on. I also looked at the malfunction procedures, and there's nothing that covers that particular series of lights. We knew there wasn't. The funny part about a situation like that, if you get, let's say you get, for example, a fuel cell and an AC overload the main bus, undervolt, you don't work on the fuel cells because you know the problem's probably down in the AC somewhere, so you start in the AC. And that's sort of what we did. We started working out the AC, and they were all good. Then we went up to the overload, they looked good. Then we went to the mains, and they looked pretty good except undervolt. Then we finally got the fuel cells. I didn't have idea on what to do.
That's Al Bean reporting on the lights that came up during the launch phase. We're at 190 hours, 21 minutes now into the flight. Apollo 12, presently 176,662.4 nautical miles away from Earth. Velocity now reads 3,104 feet per second for Apollo 12.
Apollo 12, Houston, we're looking at a middle gimbal angle down here of about 58 degrees.
Roger. Hey, that's, we just been talking in here, and we just thought of something. When we lost the 3 fuel cells, which was at the 36 seconds, which was the first time lightning struck, of course, we didn't realize that we got hit twice. However, the platform didn't go when all the fuel cells went. So it must have been when we got hit the second time that dumped the platform. Now it's beginning to make sense. It's been bugging me all along how we lost the platform so late. We didn't know whether it just slowly went off because of the 24 volts or what, but it sounds like now what happened was that if we, in fact, really did get hit twice, why, the second time that dumped the platform.
Yeah, that may be. They've been looking over all the traces down here and talking to all the lightning experts, and I think they have some tentative ideas on that. They'll probably be able to give you some pretty concrete discussion on it when you get back.
Okay.
Apollo Control, Houston, 190 hours, 25 minutes. That was Ed Gibson conversing with Pete Conrad. Apollo 12 now 176,518 nautical miles away from home and traveling at a velocity of 3,107 feet per second.
Apollo 12, Houston.
Go ahead.
Okay, two things. First of all, I did confirm that you lost the platform at 56 simultaneously with the second strike. And also on the optics problem, we suspect that it may be due to operating the optics switch at the same time as Verb 37. We'll be coming up to you with some DSKY entries to check this.
Okay.
And Dick, could we have a clarification on something which happened a short while ago? And that was what value had you loaded into the EMS counter before MCC5?
Uh, 2.0.
2.0.
There's so much bias in that thing, it almost counts up. There's so much bias in there, it almost counts up as fast as it's counting down.
Roger.
Say, I've been wondering if we ought to, Dick and I discussed this much earlier in the flight, and wondering we can calibrate that accelerometer here in flight through the GTA, and I'm just wondering if we ought to do that, because the thing is really bad news. It's got a lot of bias on it. Maybe the GTA doesn't work in flight, I don't know, but we ought to see whether we can get that bias out of the EMS.
Pete, one thing which we're suggesting down here is to load in 102 or 100 and whatever it is and fly with that. That should help
It
you.
does the same thing. No, it doesn't either. It does exactly the same thing.
Roger.
The EMS they're talking about there is the entry monitoring system. We're at 190 hours, 30 minutes now into the flight of Apollo 12.
Apollo 12, Houston, with the DSKY entries.
Okay, wait, what? Okay, Ed, we're ready to copy.
Okay, what we're doing here is setting the optics status word or op modes to a known configuration. We do that with a verb 21 down 01 enter 1331 enter 130 enter, and then if you would cycle the optics 0 switch off and then on, and we'll be watching it down here and stand by.
Roger, Ed, copied, checking out the optics mode, and verb 21 now 01 enter, 1331 enter, 130 enter, optic 0 off, and then back on.
Affirmative.
Okay, optic 0 is off, and goes back to optic 0.
Roger. Apollo 12, Houston, that looks as though it cleared the problem. We're ready to go on with the P-23s.
Do you want another trunnion bias, or is that okay? The same one I had.
Stand by, Dick. Dick,
You have to change the whole flight.
Dick, we better go ahead and get another optics cal.
Okay.
Dick, go ahead and scratch the optics cal. Looking at it, we feel you can get away without it.
It's Apollo Control, Houston. Dick Gordon now returning to program 23, his navigational star sighting program. What they were doing there were through known disky displays, calibrating the optics. An earlier suspect was that by operating the optic switch simultaneously with hitting verb 37 on his keyboard made the optics think it should be in zero. We're at 190 hours, 37 minutes now into the flight. We presently show the spacecraft Apollo 12 at an altitude above the Earth of 176,169 nautical miles, and returning home at the present time at a velocity of 3,114 feet per second. This is Apollo Control, Houston.
12, Houston.
Go ahead.
Okay, clarification on that optics problem. If you go to optics 0 and then hit verb 37 before 15 seconds have elapsed, you can run into the problem that you did.
Okay, we understand. Thank you. And Dick says that's exactly what he did by mistake. He says from ignorance.
And 12, one thing on the your gas separator, we'd like to try and see how well that thing is working. You can go ahead and remove the gas separator cartridges and run on the H2 separator only, and continue on that way unless it's not doing the job, and then you can go back to your normal configuration.
Well, let me tell you what we've done already. We've been running our food system without the cartridge, and we've been running the gun with the cartridge for the whole flight. And the cold water output is very, very good on the food system. The hot water output still has a tendency to get some air in it, but I kind of suspect that there's just a little air or hydrogen or whatever it is in the water, and when you heat the water, that makes the air bubbles expand. And we'll go ahead and pull the cartridge off the gun and operate without it and see how that goes. We have had the cartridge on the gun the whole time.
Okay, thank you, Pete. And also, if we could go ahead and pick up some bio data on Dick and Al during the course of the day, we'd appreciate it.
Okay, I'll have them hook up. We thought we were hooked up. We forgot.
Rog, Surgeon is looking at you now. And 12, when you finish up with the P-23, we have a high gain test here. It's an engineering attempt to isolate the problem area, and we're looking for a thermal problem in the high gain antenna electronics.
Okay, very good. You got something we can copy down now? We'll go ahead and copy it.
Okay. coming at you first of all with a switch configuration. S-band transponder to primary, S-band auxiliary to tape, tape recorder, PCM analog, tape recorder to record, S-band antenna, high gain power on, high gain antenna servo electronics.
Make it a little slower.
Oh, okay. Well, let's go back. S-band transponder. Primary.
Yeah, you got Al really spoken. We don't take shorthand up here, gang. Go ahead. Yeah.
Okay, Al, are you ready? S-band transponder, primary.
Yeah, I was ready last time. I've got it all the way down to power on.
Okay, that's high gain power on, and then high gain servo electronics to primary. Okay, then set up the following attitude.
Okay, you want...
Pitch 0, yaw 6-9er, .9er, and roll 5-0. An attitude deadband of 0.5, which I believe you have in there now, so it's no change. You acquire misfin in the manual mode, and then switch to the auto react mode and narrow beam width. High gain angles for manual acquisition are -2.2 on pitch and yaw 1-9er-4. Okay, then if we detect a loss of lock, or if you detect oscillations, turn the DSE on by placing the tape recorder switch to forward. And go ahead and get data for 5 minutes and then stop the recorder. And then at that point we've got a little set of procedures we'll follow through here, and we can read them up to you at the time as you're going through them step by step. What essentially we're doing is looking at the effect of primary versus secondary transponder, or primary versus secondary electronics, and wide beam width versus narrow beam width.
Okay, I understand now that you want the transponder primary.
Al, could you hold it a minute?
S-band aux tape switch. Sure.
Okay, we'd like you to go ahead and get that optics cal now that you're finished with the P23.
Okay, start working on it now.
Okay, Al, go ahead with your readback.
Okay, you want the transponder primary, and then you want to put the S-band aux in tape. Put the receiver to PCM analog and record. Go on the high gain with the S-band, put power on with servo primary. Go to a spacecraft attitude of pitch 0, yaw 69.9, roll 50 with a deadband of 0.5. We'll acquire misfit manually. Switch to the react mode with narrow deadband, and those angles are -22 and 194. And if we notice a loss of lock, or we notice that we get oscillations, we turn the recorder on for at least 5 minutes.
That's right. And if you run into a loss of comm, you'll be able to pick us up on Omni Bravo.
Roger. Houston, Apollo 12.
12, go ahead.
Hey, Ed, on this optics cal, this maneuver, as you people down there on the ground are obviously noticing, is quite a ways away from those attitudes where we're doing the P-23s themselves. For the next series of stars, I haven't looked at them yet, but for the next series of P-23s, we can check that to make sure that we don't have this large maneuver. We'll look at it also right now. And if we do, let's pick a different star for the optics cal
Okay, Dick, we understand that.
See what I'm talking about?
Raj, we understand that request. It's a good idea. We'll be doing that.
Maybe the angles are such with the sun that we don't have one, but I think you can give me one near the P23 attitude that I can use for a front-end bias or optics cal. If not, I can always use star 12.
Raj, we concur with that down here. We'll be doing that for you, Dick.
Hello, Houston on me. Delta, how do you read?
We read you loud and clear.
Okay, you got the Disky, there's his first optics cal.
Raj, we're looking at it.
Okay. Here comes the second one. There it is. And there's the third one. And there's the fourth one. Okay, Ed, that's it.
Okay, that looks good. Thank you.
Okay, now we'll go ahead and maneuver to the attitude for this S-band.
Okay. '12, Houston.
Go ahead.
Those sightings look pretty good. You had a good state vector in there, and the sightings essentially changed it so your re-entry angle changed by just 0.035 degrees.
Okay.
It's Apollo Control, Houston, at 191 hours, 1 minute now into the flight. Oh. That was Ed Gibson talking to Pete Conrad. We now show Apollo 12 at a distance away from Earth of 175,439 nautical miles.
12, go ahead.
Ed, this is Dick. Would you ask the guys there to determine whether they want me to do a 47 or leave it the way it is? I want to play this P37 a little bit later.
Roger, Dick.
What I'd like to do is go ahead and leave the state vector in there that I've got and see if I can improve on it with the next series of marks.
Dick, we concur. That sounds good. Go ahead and do it that way.
Thank you.
And Dick, when you like, we could take a look on at your next set of P23s on page 3-173 and look at your second optics scale.
What do you mean the second one?
Okay, well you do the first one and then about 30 minutes later, 30 or 40, you probably want to pick up a second one.
Yeah, that's true. If I can get myself in gear and get going, I can get all those in before 30 minutes are up. However, go ahead.
Okay, if you don't get them all in before you require another one, perhaps the easiest way to do it is to just pitch up 57.5 degrees so that your zero line of sight is then right along star 160. That's probably the smallest attitude change.
In other words, go ahead and pitch up 57.5 and use star 160 for the intrinsic bias count.
Roger, if that's a star you happen to be going to next. That's affirmative. That's a star you happen to be working with.
Okay. Okay, I'll do 160. I can get that in another half hour with no strain. I'll do star 160 and then pitch up 57.5, do a cal, and press on.
Roger. Actually, any star you're working with, whether it's 160, 171, or 163, whichever one you happen to be at.
Okay. I understand that figures. 12.
12, go ahead.
And I'd like to think about this pitching up 57. Whether I pitch yaw or a combination of it depends on the shift angle for that particular star, does it not?
Roger, Dick. We were just talking about that down here. That's a pilot pitch of 57.5 degrees, and it may be getting you into the problem with the middle gimbal angle. What we can do down here is, and plan to do, is to work you up a calibration star for each one of the stars you'll be working at, and we can give it to you at any time you want it during the P23.
Okay, well, that sounds like an awful lot of work. Why don't you give me a normal nav star, or a star that's in the vicinity of roll 090, pitch 329, yaw 332. Give me a star that's close to that.
Roger, okay, we'll do that, Dick. 12, Houston, could you go on back to balance couples now?
Oh, sure can. Thanks for reminding me. We should do all our maneuvering on that except for the actual P23. And we really intend to.
Roger, Dick, that makes it a little easier to keep track of, or to make sure we got a good state vector for you.
Right, I understand all the problems, but just during the marking I'll want to be in the unbalance, but all our maneuvers should be with balance couples, I agree.
Guess that vehicle is a little sensitive right now, isn't it?
It sure is if you have 2 jet minimum impulse. Houston, that was your alert light. Did you see it?
Stand by, 12.
Apollo 12, Houston. Apollo 12, Houston.
Go ahead. Did you get your crew alert light down there?
Apollo 12, Houston. Houston did not send a crew alert. We're checking with the sites now.
No, you misunderstood me, Ed. We had the gimbal lock light on.
Okay. Yeah, we misunderstood.
We didn't. Yeah, we didn't put it gimbal lock, but the alert part of it was on.
Apollo 12, Houston, we would expect that light, and you're still about 15 degrees away from getting into a problem.
Oh, yeah, we're watching it, Ed, but we got another problem here. Look at our attitude. I got a 50-18, and I can't maneuver automatically away from this thing. Do you think we ought to zero the OCUs one time?
Dick, say again your last comment.
Well, look where we are. Here's our attitude, and I can't maneuver past this automatically. I got a 618, and it says we're there.
Okay, Dick, stand by.
No, we're there. We're right there. We're okay. Hey, we're crazy up here. We're all right.
We agree with your last comment.
We'll explain this to you later. We don't want... Well, we'll explain it later. We have a good reason for it, but we don't want to tell everybody.
Okay.
What are you saying is we're dum-dum up here.
No, we agree with the last comment, not the first one. Apollo 12, Houston.
Go ahead.
We got the folks down here thinking about the difference between a 5018 and a 618. Are you thinking about the same thing?
No, we were just dum-dum sitting here looking at 69 degrees of yaw, which is sitting right next to gimbal lock, and 0 pitch, and wondering why we were sitting there and it wasn't maneuvering when we were really in the right place, that's all.
Roger.
We're just not used to sitting in an attitude like this where we're looking at a red ball Hey, Ed, I have a feeling we're telling you too much and you're all getting nervous down there.
Apollo 12, Houston, would you confirm that you've got the switch configuration as we've read up, and then also if you've gone to react and narrow beam?
Roger, it's all set.
Roger. Okay, now in that attitude, we got the sun looking right up the engine bell, and that ought to be heating things up as fast as we can do it.
Okay. Don't forget we've been operating secondary servo up until about 5 minutes ago when we switched to primary for this test.
Roger, Al. Apollo 12, Houston, we see no FM subcarrier down here. Would you confirm that the S-band recorder, or S-band aux is to tape?
It's a tape.
Thank you.
How about a reset? How about a reset, yeah. Give me a reset.
Roger. 12, Houston, we have the subcarrier now. What we're going to be doing now is just sitting here and seeing if the problem will appear. And we're looking for a 6 degree decibel dropping signal, or you report a hunting in the antenna.
Okay.
And 12, this could go on for a little while. We'll continue this for 4 hours or until a problem is identified.
Okay, very good.
Apollo 12, Houston, while you're sitting there backed up to the fire, we have some news for you if you like.
Go ahead, Ed.
Okay, 12, there's some pretty good football games on tap for today in the college ranks. Ohio State and Michigan tangle in a Big Ten game. The Buckeyes are favored to win and retain their #1 rating. If Ohio State does win and retain its #1 ranking, it will be the 6th time in modern football history that a team has won the title 2 years in a row. In other games, UCL is favored over Southern Cal. Purdue is favored over Indiana. Oklahoma is a choice over Nebraska. And TCU should beat Rice. Princeton plays Dartmouth, and Washington meets Washington State, and we're not guessing on the outcome of any of those. Texas University is open, and they're looking towards Texas A&M on Thanksgiving. Houston is picked over a tough Wyoming team. We'll keep you posted on the games that are going on this afternoon. Texas is now accepting ticket orders for the Cotton Bowl and the Sugar Bowl. The winner of the Texas-Arkansas game on December 6th goes to the Cotton Bowl to face the Fighting Irish, and the loser will play Mississippi in the Sugar Bowl at New Orleans. Willie McCovery of the San Francisco Giants beat out Tom Seaver of the Mets for the National League's Most Valuable Player Award. The big game in pro ball on Sunday is the Dallas Cowboys against the Los Angeles Rams. The Oilers will be playing the Miami Dolphins down in Florida. Meanwhile, the Oilers report that linebacker Ed Watson has been placed on waivers to make room for Woody Campbell. A Delta launch vehicle has placed Britain's first communications satellite into an orbit from Cape Kennedy. It's called Skynet. Now in an elliptical orbit, the satellite will be placed into a synchronous orbit of 22,300 miles on Sunday. Ending world and national news headlines. The Senate has rejected the nomination of Judge Clement Hainsworth by a 55-45 vote. Henry Cabot Lodge has resigned as ambassador to the Paris peace talks. And Charles de Gaulle is 79 today. All 3 Apollo 12 wives wowed the news media yesterday as they paraded out of the Conrad House in stunning white suit pants. They each carried a sign which said, "Proud, thrilled, and happy." Family activity will be rather restricted this weekend. Dick, Barbara will attend Mass this morning at 8:30. And Al, Sue will attend a luncheon today at the Lakewood Yacht Club and will visit Mission Control this afternoon at about 3 p.m. Pete and Jane will be going shopping today for Chris's birthday present. She is also scheduled to go to the Yacht Club for the luncheon. On Sunday after church, they plan to go on a picnic at Cloverfield with the Rices. Your father-in-law is expected to arrive here sometime Sunday and will remain till after splashdown.
Hi, kid.
You're welcome.
Thank you kindly, and tell those Huskies to get after those Cougars today.
Will do it, Dick. And 12, it's been about 5 hours now since you started accelerating back towards the Earth.
Good.
This is Apollo Control Houston at 191 hours, 33 minutes.
Your edge, and I have us at 15.97 degrees north and 91.62 degrees east.
Roger, Dick.
And I have us at 174,480 miles out to Earth, traveling at 3,150 feet per second. And our entry angle to the Earth at this time is minus 78.11 degrees.
Dick, that sounds good. They're all right on.
It's Apollo Control Houston. That was Dick Gordon reporting our spacecraft distance from Earth and velocity. The reference Ed Gibson made as he, just prior to reading up the news, the reference to backed up to the fire refers to the attitude which the spacecraft is currently in, which puts the service propulsion system engine bell toward the sun. They're in this attitude running a test on the communications system between the spacecraft and the ground. These procedures being passed up a short while ago to them. We're at 191 hours, 35 minutes into the flight, and this is Apollo Control Houston.
Houston 12.
12, Houston, go ahead.
Ed, we'd like to have you keep track of one more thing. We have done a GDC alignment at the start of this test when we got to this attitude. And before we come out of it, I wish you would remind us to review our angles on the GDC. This thing's been drifting pretty badly in yaw the whole flight. In fact, it's up to, I think, pretty close to 10 degrees an hour in yaw. But we'd like to give you the numbers when we get out of this, just before we get out of this attitude.
Okay, Dick, we'll do that. Apollo 12, Houston, with some news on how your LSEP is doing.
Go, man.
Okay, the central station is still performing well. RTG output is around 73 watts. And as of just a short while ago, they've sent up a total of 382 commands. PSE has gotten into a stable temperature equilibrium around 126 degrees. And they have observed three different times the tracings have showed that there was some seismic activity taking place. The LSM is increasing in activity as the moon is entering a magnetic zone between the Earth's two solar shock waves. That is, the moon is approaching the center of the Earth's magnetic tail near lunar noon, where the field is the lowest. And at that point, the LSM site survey will be accomplished. And the solar wind is perking right along and doing real well.
Say, Ed, from all they know now about watching the temperatures, do they forecast this will last for 2 years?
Okay, folks down here are pretty optimistic, but I'll have to ask to see if we can really extend it that far. I'll try and get you an answer to that, Al. And 12, Houston, the folks down here have thought a little bit about your two EVAs, especially the geology involved, and have a few questions which were stimulated by what you said during the EVAs and after it. And any time that you'd like to have a discussion of those questions, we're sitting here waiting for you.
Okay, Ed, we're in the middle of a big garbage cleanup right now, and as soon as we get the place spruced up, we'll be with you. It takes about another hour or so.
Okay, Pete.
Apollo Control, Houston. We're presently at 191 hours, 48 minutes into the flight. And now show Apollo 12 at 174,000, 29.8 nautical miles out from Earth. And coming in now at 3,159 feet per second. We'll keep the line open and continue to monitor any conversations as they develop. That was Ed Gibson passing along the news of ALSEP to the Apollo 12 crew. This is Apollo Control, Houston.
Apollo 12, Houston, in another 3 minutes we'll have a sight handover and you'll get a temporary loss of signal.
Okay. Houston 12.
12, go ahead.
Roger, we've completed our little sweep down there, and we're ready for your questions.
Okay, Pete, we'll be with you in just a minute.
Apollo Control, Houston, at 192 hours, 17 minutes into the flight. That was Pete Conrad calling capsule communicator Ed Gibson, saying they're ready for the geology questions.
One question is, could you give a little more elaborate description of the pattern ground with the ridges and grooves? That is, were there several scales of the patterning? And was there a difference in the bearing strength of the surface on the patterned ground?
You're referring to the things that look like streaks, and that we talked about that were in different directions also, that the lamp, so that they weren't effects of the lamp exhaust plume. Is that what you're talking about?
Yeah, you described some which were perpendicular to the direction which you thought the exhaust plume would normally give pattern ground.
Yeah, if I remember correctly, that was in the Surveyor crater, and I think that we notice these radial streaks almost everywhere. Don't you agree, Al? Yeah, we'd see some, and then we'd go through an area that wouldn't have any, and then we'd see another area, and then there'd be an area that didn't have any. So we were seeing them frequently. You know, they weren't very isolated, but they were all over. The ones down in the Surveyor crater were from looked to me like this northeast running southwest, would you say? And then maybe the ones out in front of the limb, for example, they were north running south and maybe northwest running south. I can't remember now, but I'm sure it's on the voice tape. As nice as I recall them, Peter may recall them differently. It's hard to remember, but some of these things, they looked to me like they were about maybe an 1/8 of an inch to a 1/16 of an inch in wide, and they maybe were, if you looked at them real close, they looked like they were about 1/16 of an inch high or less, and then maybe then they were about 3/8 of an inch between little hills. Something like that would be my guess. What do you think, Pete? Yeah, I agree with that. Now, you mentioned bearing strength. I think the bearing strength of the ground generally speaking, in the Surveyor crater and up around as we approached it from the far side on our traverse and everything, was probably some of the firmest ground we were on, the ground that we sank in the least. There was that one place we got into when we got out, way out was a sharp crater, Al, where we felt that the ground was much more soft and powdery, and we were therefore not as good bearing strength.
Yeah, I think it was sharp. That's a thing too.
And I can't say that I remember any radial patterning out there as sharp, but to speak of.
I don't remember any either. One thing, we know we did that gold camera right at the very end, and I don't think I was able to get any of that pattern ground. I should have, but the time just ran out, and before I could get very many pictures, we came back in. I did take it with a 70 millimeter several times.
Well, Roger, over what extent did that pattern ground occur, and can you relate it to anything that you've seen back here?
Well, I don't think we paid that much attention to it, other than when we were aware of it, it was all around us like the Surveyor crater. Going down, I guess walking down to the Surveyor is when we noticed it in there while we were resting. And to what extent it went, I really can't say. But like Al said, I think we came across it in several places. And I don't think it's more an impression than anything else, but I really don't remember it out there by Sharp Crater or anything, and that's where the ground was sort of soft and maybe finer grained. Yeah, that we've been on. So that may be a very pertinent point, that the more firmer ground that we were on, the more we would see this radial or pattern streak.
Hey, and that's something else I hadn't thought of, Pete. Remember that firm ground also was the same ground we came up on when I said it looks like this ground has got kind of little blobs in it, and it looks like what a nice, smooth, level dirt field would look like if it just had the very light grade on it. Yeah, remember when we looked at that? That was, you're right, that was when we were on firm ground right there. That's a good one. I hadn't thought of that. I do remember looking at that patterned ground to see where it went. And usually if I was near it and looked out in the distance, it looked like it went in the direction of the grooves. As far as I could see out in that direction, you know, and be able to see any detail that fine. In other words, I never did look either left or right on those groove patterns where it did look to me like it went all the way out to the limit of vision for seeing them. I never saw any sort of contact along the transverse direction of the grooves, either in Surveyor crater or in front of the limb or the couple other places we have to walk around. Yeah, now that you mention it, we saw, I guess, at least three basic type of ground. The one that we were on most of the time that we discussed, like right outside the limb, we saw the kind with the grooves. We saw the kind with the little, like, raindrops on it. And of course, we got pictures of all the different kinds. And then we saw some more finely powdered ground, like out around Sharp Crater. And then we saw some more finely powdered, like just down on the inside of the small craters, and to some extent on the inside of the Surveyor crater. Those are all the different types of soils that I can recall.
However, they all had the same color. Boy, there was, other than the fact that you suddenly aware that you sunk in further, or you just have to be thinking about it or looking at it at the time, there was no distinguishing in colors or anything like that. Now, there might be a subtle enough distinction in colors that from a far distance, that's where rays out of these craters give you that pattern. But when you're standing right up close to it, that was not at all apparent that there was anything different in color.
Yeah, that color is so deceptive. I can recall now looking at all the material around the limb the first day we were out and just making some comments. I don't recall what I said, probably more gray-brown or gray-white. And the second day I was out, the very same places, and I wasn't really aware of it. At the time, I kept talking about them being light brown. All the rocks I kept thinking had a light tan coating, whereas the first day, I thought they had a light gray coating. My impression now is, and it could be completely wrong, but I'm going to be anxious to see the rocks when we get home, is we picked up all the different kinds of rocks we saw that had to do with texture and shape and anything else we could see, which wasn't much, believe me, I looked hard. But my impression is we're going to crack those rocks open, and when we do, we're going to find, and we should have done this on the lunar surface with a hammer, we're going to find that those things are dark gray basalts. Also, every time we came in the limb, both times, Pete's suit and my suit looked the same gray color. I never saw anything but that dark gray. I never saw any of the browns that I'd seen outside or anything like that. Yeah, our suits look like we've been wallowing around in graphite. A dull graphite. That's right, it was about that thin, fine to it, and it clung to everything.
There were some points there where you talked about seeing large white boulders in the distance, or on other occasions seeing things which appeared white. Do you really think that was the color white, or do you think it was the way in which the sun was refracting off of those surfaces that you were looking at?
Well, we discussed that again when we got back up in orbit, and the fact that at the high sun angles, the ground looked white to us from orbit and everything. And I think it's purely a matter of that the sun is so bright that when it shines on those objects at a distance, and you're very close to having the sun directly behind you, that it gives the appearance, everything has the appearance of being chalk white. I think that's one of the most different things about the lunar surface that I saw from the Earth's surface, was the fact that where the sun is has such a great effect on the color. Whereas you take on Earth and have some sort of rock laying on the ground, the sun can move a long way, and the rock still pretty much looks the same. And when you pick it up and kind of shade it with your body or something on the ground, you can usually get a good index of the color. You do that on the moon, and you just can't hardly see the rock. And when it's in the sun, it just changes colors with the sunlight. That's one of the most predominant differences that I can see. Yeah, now, Al mentioned a very good point. There's no doubt about it that the ground looked different the second day than the first due to the sun angle getting higher. However, on the horizon remained approximately the same. And again, I think it's because of the greater distance and the fact that the angle between us and the sun was still relatively small, looking at a distance, and the rocks still looked white out there, chalk white. Now, I'll bet if we stayed there and let the sun move through 90 degrees, that what we saw in the distance would change in color. Yeah, I agree with Pete. Now, one interesting thing, when we were out at this Surveyor that was sort of tan, my initial impression was that the radiation or something had darkened the paint. But when you look at the chrome surface, the only surfaces I saw that didn't look this way were the mirrored surfaces, by the way. But you look at the chrome surfaces of, for example, that battery box, and it had changed to almost the same color, that light tan. Now, maybe if we looked at it the first day and it had been in sunlight, it wouldn't look light tan, it would look like gray. But it looked like tan. You'll be able to get this, of course, because we got the cameras with us. But when I rubbed the box, it took off the light gray coloring, but it just didn't dust off. So I'm pretty sure that we didn't put it on with our limb, because it wasn't just like dust that hangs around your house. It's only been there a day or two. It was like dust that's collected on there for a long time, and long enough, had some effects on it long enough till it really becomes not a thick coating, but a very cohesive coating. It was almost like a skin on there. And you had to rub hard to get it off that battery box. And when you did, there was a nice shiny chrome beneath it. It was kind of a strange thing, like a bunch of dust had blown on the box, and it had stood there long enough to really get hard. Well, I think there's going to be enough parts that have not been touched by either our gloves or by the bag that the camera is in, that you'll be able to get a good hack on that.
Raj, I imagine also
like the TV mirror.
Go ahead, Pete.
Yeah, the TV mirror has only my finger mark on it, and I'm sure that nothing else is touched
any of the rest of that TV mirror, and it was covered with this fine dust. Also in the same place with the mirror, Pete, although our mock-up didn't look this way as I remember, there's a lot of electronics exposed in behind that mirror that, of course, we never could possibly touch. It should have the same coating in there or something. Well, the other most important thing is Surveyor was equally brown all the way around it, and had we covered it coming in, I think we'd have seen a directional pattern on the Surveyor. So I don't think, as a matter of fact, the way that dust flew when we landed, I don't think any of it landed within 10 miles of where we landed. It just took off. I kind of agree, and even if it did, it wasn't going to fall in the crater and just shoot right across it. Yeah, and the Surveyor was lower than we were. Hey, I just thought of an interesting possible point that somebody wants to do when they get with that camera, the geologists want to look at when they get the camera before they give it the scientists, is back in there behind that mirror where all the radiation could get into. It couldn't get into as much as it could, let's say, the top. The camera got radiation all day long because it'd get it the minute the sun came up, it'd get it all the way around the sunset. But inside that little hole where the mirror rotates, there's going to be parts in there easily calculable that got just only a certain amount of sun each individual day. Let's say some parts would only get 10% of the sun on the outside, some parts of the inside would get 50%. So if they're very careful with that mirror surface at the back of the mirror and inside that little hollow place, they're liable to be able to get some index of how fast this stuff builds up and when it does.
Roger, were you able to notice any kind of vertical...
I have to be careful.
Go ahead.
I think you're going to want to have something thought through on that before that camera goes whistling off in the distance, because it isn't going to take a lot of fooling around with before all that information would be lost.
Yeah, that's true. We'll have to be careful how we handle that. Did you notice any vertical gradient in the color on the Surveyor as you might expect if it was dust?
No, it was pretty well uniform all the way over it. He brought out a point that's strange too. It was all the way around. It all looked the same. See, we approached from the opposite side that we landed, and that was our first impression. Coming up on the opposite side it was brown. It didn't look brown the day before in the shadow either. It looked white. And of course it was out in sunlight by the time we got to it on the second EVA.
Okay, a question on the vesiculation of rocks. Did you really notice any or an appreciable amount of vesiculation in any of the rocks you saw?
Not a one. That's what's funny. I guess Neil and Buzz brought some back, and we didn't see one rock anywhere with any that type structure. I agree with Pete. One time I reported I did, and then I looked at the rock when we finally picked it up, and it didn't look like it at all. It had a bunch of pits on it, but it didn't have any vesicles in it, and we were all doing something else, so I never really went back and corrected myself. But I kind of agree with Pete. I never saw any vesicular material at all. I'm not convinced that we got too much different kind of rock material, to tell you the truth. Of course, I got fooled out there in the desert, and so anything that we saw that remotely resembled being different, to our eye, we brought you a sample. Yeah, I think we got a sample of almost everything that was there. Everything that we saw that was different texture, or the way it weathered, or where it was setting, or anything else that seemed unusual to us about the differences of rocks, we grabbed some of them. But like Pete says, it's going to be interesting to see how many different things we did actually get.
Pete, now were you able to notice any which appeared to be boulder tracks on the head crater or any of the other craters, similar to the type of tracks you saw after you rolled that one rock down?
Well, let me say this. I was without walking down at the crater. I couldn't tell what kind of a track the rock made that I rolled down there to start with. However, I think we have enough pan photos that you can stereo in the craters that we went up to, that if there are any boulder tracks, you're going to be able to see them.
Yeah, I think that's the best point right there. We took enough, so you're going to find them. I don't remember seeing any myself, but I think I also don't remember specifically looking for them. Usually when you see them, if you see anything special like that, you'll remember it. But maybe there's some around I just didn't even notice them.
Hey, let me ask a question down there. When we were in orbit, we passed a particular area, and I'll have to go back to the map and look, where there were 3 or 4 bright craters that had very, very dark gray material streaking down the sides of them like landslides. Now, we were aware of many places, but using the binocular, of seeing landslide type or slide or slump in all the craters all around the whole moon that we could see. But there were only these 3 or 4 craters that had very decided gray slumps or streaks or something that almost gave you the impression that there had to have been a liquid spill or something. It was so different than anything else. Has anybody reported that, or have you seen them in your photographs from Earth before?
We'll try and get an answer to that, Pete.
That boulder track business got me thinking about that. Go ahead with your question.
Yeah, let me say something else too, and I can't remember if I said it. You know, when we talked with Al Chittister and the guys before we went about the main objectives of the geology wasn't to go out and grab a few rocks and take some pictures, but to try to understand the morphology and the stratigraphy and what have you of the vicinity you're in. Look around and try to use your head along these lines. Well, I tell you, it wasn't less than 10 times I stood in spots, including in the limb, both times we were back in, and said, okay, Naveen, what can you do in that? Can you fill that square? Is it possible to look out there and try to determine where this came from, which is first, which is second, and all that? And except for deciding which craters look newer than others, which we know from ground observations, I was not able to see any special little clues like we were, for example, over in Hawaii, and we were when we were out at Meteor Crater and other places that gave us those kind of clues. That whole area has been acted on by these meteoroids or something else, so that all these features that are normally neat clues to you on Earth are not available for observation. I didn't find any way to fill those 2 big squares. You know, I never was able to walk it up to a crater to determine when the normal ground stopped and the ejecta started, except on the difference in slope or the fact that it got a little bit more powderier under my feet. And that's not a very good index. We never saw anything of a different color or a different amount of rocks or anything else, except the times that Pete and I were picking up that very light gray as opposed to the more dark cement gray material. There's just no contacts to look at. I think even a trained geologist would have trouble doing a whole lot of field geology that way on the moon. I think what you're going to have to do is pick your traverses like we did and just sort of select at a regular interval as you go along, and then come back and analyze this stuff to find out differences. I've kind of got the idea that a lot of it is the same, and the only difference being its relative age to one another by being blasted by a meteor coming in and getting thrown out at different times. Don't you think that out? I think one of the things you're going to want to up too, you're going to want to up the number of core tubes so that you can get down in these areas you're interested in and find out what's going on under there, because it's covered with this layer and there just ain't no way to figure it out. I know, thinking back, and like I say, before the EVA, during the EVA, and afterwards, we talked about it and thought about trying to get the big picture, trying to be more than rock collectors and picture takers. And believe me, we worked at it, and I think from our training we were pretty doggone good at getting that sort of thing in training, not just grabbing a few rocks, but trying to evaluate the things that we want to evaluate. But it just was difficult to do because the clues just aren't right laying there on the surface. It's got this big blanket of all beat up soil over every single thing. I think maybe you want to get a better trenching tool. Pete, the trenching tool we had was just that shovel, and he could only go down about 8 inches without falling on his head. Now, if you don't want to get a lot of core tubes, but you want to see what's going on, maybe we need to get some sort of better trenching tool where the guy can lean over and trench down 6 or 8 inches, or at least as far as the ground is soft, and then take a look at down what's underneath it. We were really hindered in the fact that we could not bend over. It wasn't as apparent in our training as it was up there, because in your training, when you weigh 285 pounds there in the building and you got all that stuff on your back, it's fairly easy to sort of squinch down or lean quite a bit. You can't do that up there on the moon. And like Al just said, and I'm short and low to the ground to begin with, and somebody as taller than I am is going to have a difficult time with the same length tools trenching as deep as I did, because you just can't get over. And we've got a whole bunch of ideas, and we're going to, in the 5 days there at the MQF, we'll put all this down on paper on what we think we could do to pass on some suggestions to improve the tools that we have right now to do a little better job. Yeah, I think those tools can really be worked over. They seemed pretty good before we left, but once we got up there and started working with them, in that 1.6G, and like Pete says, you can't always do the same things. You're leaning in a different way, and things are a little different. I think we thought about it enough and observed it enough that we could come back and give some pretty good suggestions for tool improvement and equipment improvement along those lines. It'll help the next guys get more rocks and better rocks and faster and trench deeper and do more core tubes or whatever else they want to do. You tell them they can start fixing that doggone hammer.
Okay, thanks for your comments.
Yeah, we concluded that everything's too delicate to start with. The extension handle was about wiped out by the time Al got done driving that double core tube.
Yeah, even though you're light up there and everything's light, you can still get something like a hammer swinging, or if you get moving and want to stop, you can still put some pretty good loads on some equipment.
Okay, Pete, now that's it for the questions. Thanks very much. Could you give us a reading off the O2 pressure gauge on the repress pack?
Yeah, one more thing that we did get back to this crater morphology and all that business. When we looked at those craters, we tried to do that too. Because we could see bedrock, or what we thought was bedrock on the outside. We said, great, we're going to look at those craters. This is what we said before we even got out. We're going to look at those craters, and we're going to see a neat contact between the regolith and the bedrock. And then we're going to go down a little bit further, and here's going to be something else. We really got it knocked. We looked at those craters, and what it looks like is just like the surface, except there's a few rocks that seem to be resting on the wall and resting in the bottom. Now, if you went down there and dusted away all that material, I don't know how much there is there, maybe you'd find a contact between the regolith and the ground bedrock, but, you really couldn't see it. Now, maybe you could infer it from the pictures we took and what we discussed, because it usually was showing here and there, particularly on that very last crater. But that's good. That's going to take some work. It's just not like looking at a crater on Earth.
I think the fact that it has this makes geology up there as difficult, if not more difficult, as it is on the Earth, because you have trees and grass and all kinds of things like that hide a lot of the Earth's geology. So I think you're in the same box up there. What's been the repress package is 850 psi.
keep talking about going to all these neat places like Hyginus Rill and all that stuff because we're going to stand on a side right below the rill. We're going to look up on that big high side, and right there is going to be the history of the moon, like sort of like the Grand Canyon gives us such a great one of the Earth. Well, I'll tell you, if the sides of that place are anything like the sides of craters or the sides of the Surveyor, you're going to look up there and you're going to see a bunch of dust just like you see on the surface. Unless there's, you know, I could be easily wrong. We hadn't been there. But we just didn't see any places, no matter what the slope, that didn't have all this material all over it.
Roger.
This is Apollo Control Houston at 192 hours, 46 minutes into the flight. You've been listening to a long discussion on geology between Pete Conrad and Al Bean aboard the spacecraft and Ed Gibson here in Mission Control Center. Along with Gibson at his side is astronaut geologist Jack Schmidt, who was working with Ed in preparing the questions. While we have a slack moment in conversation, we would like to pass along an announcement. There will be an ALSEP briefing for newsmen in the main auditorium at 12 noon today.
So the VC counter, it looks as though the thing's working pretty well from what we can determine. We've looked back at mid-course 2, LOI 1, LOI 2, and the lunar orbit plane change, both of them, and TEI. And it looks as though it's the predicted and the crew readout are doing pretty well. They're pretty close agreement.
Okay, that's it. What you say is generally true. Yeah, and the reason I say that is because those burns, the thing is being held up until about 20 seconds or so before burn time. I measured the pip of bias exactly one time, and it came out to be 1.4 feet per second in 1 minute, which is within tolerance. And there's no question about that. And the only other indication I've got is that on the delta V test, you put 56.8 in, and run it to 10 seconds in the delta V test, it always comes up with minus 18.1, which seems to be a little higher than we would expect to see, although it's still perfectly within tolerance. I see nothing wrong with it. During the RCS burn, a burn took a little bit of time to do and to trim out, and during that time, the pip of bias, or the bias in the accelerometer bias, the EMS, was actually almost as high as my ability to trim. So that's why you got such an erroneous reading on that. And that had a little something to do with the separation from the booster after PLI also. But I'll talk about that later.
Apollo Control Houston, we presently show an altitude of...
Within tolerance, however, Dick.
Oh, that's correct. I recognize that. I just wanted you to know that that's what we've got, and I guess that's just real world.
We presently show an altitude of 172,138 nautical miles above the Earth for Apollo 12. Now traveling at 3,208 feet per second.
Hey, one last comment there, Houston. How about telling old Hugh Clinton that we both thought we were in Kapoho 2 when we were on that moon, and we gave him about the same type of information that we gave him at Kapoho as far as it was visible.
Roger, Al, will do.
This is Apollo Control Houston. Kapoho is on the big island of Hawaii. We're at 192 hours, 51 minutes into the flight.
Houston.
Go ahead, Houston.
Say, if it's possible for you to see out of the rendezvous windows, to get a good shot at the moon. We'd like to get some more small-scale, high-latitude photographs, and this would be at your convenience. If you think you can do it, give us a call and we'll give you some procedures.
Okay, now we just took some, about 2 hours ago, some 250 millimeter of the moon, which of course are full frame. Would you care for something now? And what lens would you like?
Sounds as though you pretty well outguessed us. It'd be a Hasselblad with a 250 millimeter lens, black and white film, 5.6, 1/250th, and of course at infinity. And if you take 2 or 3 photos and repeat approximately 30-minute intervals for 1 hour.
Okay, we'll tell me the f-stop again. That's the only thing I didn't hear. Oh, okay, we got it. I'm sorry.
5.6.
Okay.
Al, Houston.
Go ahead,
Apollo 12, Houston, are you observing any variation in the antenna position at the present time?
No. I've been sort of watching it, and the only thing I've noticed this whole time is every once in a while the yaw will just wiggle one time, just a smidge, and that's the only thing I've seen. Otherwise, it's been steady as a rock.
Okay, we just picked up a little variation in signal strength down here.
Okay, now wait a minute. That just made a liar out of me because it's just starting to do it up here. We got signal strength variant, and it's doing it in yaw.
Roger, we've just started to pick that up down here. DSE on, please.
Oh, put DSE on, roger. Okay, now the recorder's on and then we're in low. Do you want us to go to high bit rate?
Affirmative, high bit rate.
It's Apollo Control, Houston, at 192 hours, 59 minutes. Apollo 12 going through a test exercise now with the sun looking at the face of the antenna. We presently show Apollo 12 as at 171,819 nautical miles away from Earth.
Apollo 12, tape recorder to stop.
Okay, that's done, Ed.
Thank you, 12. It looks as though it's settled down. Let's just keep an eye on it. 12, DSE to forward.
Yep, we got it.
It's Apollo Control, Houston, the DSE being data storage equipment. It stores data and voice information during flight and during periods of lost communications and plays them back later. We're at 193 hours, 4 minutes into the flight. Apollo 12 now at an altitude of 171,664 nautical miles above the Earth. Present velocity 3,212 feet per second.
Houston, Apollo 12.
12, Houston, go ahead.
Roger, Ed. Let me give you the angles on the GDC at this time.
Go ahead.
Okay, roll 072.25. Pitch is 352.4. Yaw is 081.55.
Roger, Dick, copy 072.25, 352.4, 081.55. Thank you.
Roger, I'd like to get another one.
Okay.
Houston 12.
12, go ahead.
It looks like what the antenna's done now is driven to some position other than optimum, and it's just sitting there.
Roger, Pete. 12, would you go to wide beam width?
Roger, wide beam width.
Thank you. Apollo 12, DSE to off.
Roger, it's off.
Apollo 12, is the antenna holding steady at the present time?
As best as I could tell it is, Ed, it's moved a little bit from where it was a little while ago, but it's not wobbling like it was doing the other day.
Roger.
I take that back. It may be wobbling just a little teeny tiny bit. I can see just a very slight oscillation in signal strength, and maybe, of course, our gauge is not too steamy for being showing fine reading, but it looks like it might be oscillating a degree or so.
Roger, thank you.
And that's normally a yaw.
Roger, yaw.
I remember the other day when we were in the lab and Dick was having that trouble, it was oscillating to both axes, pitch and yaw.
12, Houston.
Go ahead, Ed.
For your next P23 at 195, we have another calibration star, which I think will work out a little bit better for you when you're ready to copy.
Go ahead.
That's a star 24, Gyna. And the attitude is roll 092, the pitch 329, yaw 0. And that should give you a pretty small angle difference between the next attitude you'll be going to.
Okay, thank you. Appreciate it.
This ought to be a very interesting one too, Ed, because I noticed on the other series the first series of P-23 that Gina was pretty dim in the normal optics mode, but I'll be interested to see if I can see the star through the landmark line of sight, and I'd like to try it. That sounds good to me.
Roger, Dick.
Apollo Control, Houston. That was capsule communicator Ed Gibson talking to Dick Gordon concerning his next set of navigational star sightings. We now show Apollo 12 at 171,111 nautical miles away from Earth and traveling at a speed of 3,222 feet per second.
Apollo 12, Houston, would you put the DSE at forward, please? At 12, could we have the track mode to narrow?
You got it, Ed.
Roger.
Man, is this chocolate pudding and butterscotch pudding ever good? You gotta try some.
Roger, Dick, I'd like to trade you.
Not yet, Ed, not yet. 2 more days and you can.
So Apollo,
Houston, could we have secondary electronics?
Secondary electronics coming at you.
so Apollo Control Houston at 193 hours 42 minutes into the flight. You heard a brief earlier comment from Dick Gordon about the chocolate pudding, butterscotch pudding, and the chocolate pudding. Obviously undergoing a lunch break. We show Apollo 12 presently at 170,488 nautical miles, traveling at a speed of 3,236 feet per second. Continuing to monitor, this is Apollo Control Houston. This is Apollo Control Houston at 193 hours 44 minutes into the flight. Apollo 12 now at an altitude above Earth of 170,438 nautical miles, traveling in at a speed of 3,237 feet per second. At this time, we will take the release line down to allow you to listen to an ALSEP briefing which will be taking place shortly in the main auditorium of Building 1. This is Apollo Control Houston.
This is Apollo Control at 194 hours 38 minutes. Apollo 12 is 168,721 nautical miles from Earth. Velocity 3,275 feet per second. Crew of Apollo 12 is now in the process of doing Cislunar navigation. This exercise moved up 1 hour from the flight plan. At the completion of the S-band high-gain antenna test, it was decided to proceed on with the P-23 navigation sightings, rather than go into passive thermal control for an hour and then start the sighting. So that Cislunar navigation was moved up 1 hour, and the crew is in the process of doing that now. There's been very little conversation during the ALSEP news briefing. What conversation there has been has pertained to either the antenna test or the navigation sightings. We have turned that tape over to the transcript people. We will now continue to stand by live for any further air-ground communication.
Houston, Apollo 12.
Go 12.
Guess what? I don't have a star.
I'll say again, please.
I said I don't have a star.
Dick, you're going to have to try that once again. We're breaking up in communications and we don't read you down here.
Roger, how do you hear me now?
Still breaking up, but probably readable. Try it.
Okay, I do not have a star for star number 5, 6. For 6 set star 204.
Roger.
Tell the boys in the back room I don't have a star for this particular one in the field of view. I can't see it.
Roger, we'll work on it. Dick, part of that test, we wanted to make sure whether or not you could not see the star because of light shafting. Was that the case?
Well, it's light out there. I don't necessarily see any light shafting, but I sure can't see the star in the field of view.
Roger.
I don't know why or what the reason for it is.
Okay. nav star then is star 24 and the Earth far horizon.
Okay.
The Capcom is Don Lind.
Apollo 12, Houston.
Go ahead.
We'd like you to dump the wastewater down to 0 before you go into the PTC. Then we won't have to disturb that later, if you would, for us.
Okay, stand by. I want to get this bias, try and bias hit.
Sure, any time before you set up PTC.
Don, this is Dick again. Where do you want us to take the wastewater down to before PTC?
Take it clear down to 0. Then you'll have an undisturbed night's sleep.
Okay, you're not worried about that bladder all the way down to 0, huh?
Roger.
Okay. Houston 12.
Go.
Don, I was curious on that 6th set. When they use star 204, how close is that to the sun?
We're looking it up for you, Dick. Dick, that was 20 degrees, 20.
It seems like I should have been able to see it then, huh?
It's in that area where it's kind of marginal, Dick, and we were kind of interested whether you could or could not see it.
Okay, well, I sure looked all over in there, and I couldn't see any star in the field of view.
Roger.
In fact, it surprised me. I thought I was going blind.
Maybe that star didn't get turned on today.
Well, I was going to accuse you of wrong unit vectors and all kinds of things like that, but I thought I better not. Don, do you want to take an E-memory dump at this time?
Give us just 1 minute to get set up, Dick.
Okay. For the navigation experts' information, this last set of stars, the air glow is starting to show up, and I'm starting to use the top part of the air glow for a visible horizon.
Roger, Dick.
That first set, it was not the case, or at least I couldn't tell that there was any air glow there that was visible. I just used what I thought was probably the true horizon.
Dick, we show you down to 0 on wastewater now. Apollo 12, we're ready for the E-mod dump.
Okay, here's coming at you.
Roger. Also, Dick, how well could you see Venus, the first star you did, and the 5th star, 163? Were those clearly visible?
That's affirmative. No problem with the stars at all. Venus, of course, looked like about 4 of them put together.
Roger, very good. Thank you.
Actually, it's a very easy planet to use for the simple reason that you can take the horizon and split the image of Venus so that you get a pretty good mark off of it.
Very good.
And the rest of the stars are so dim that you really can't do that. All you can do is get the star down to the horizon. But with Venus, you can actually split the planet with the horizon.
Roger, copy.
Houston, let me know when you're through that E-memory dump. I want to take a look at 83 and see what I did to my own state vector.
Roger, we're through with the E-mod dump now, and when you look at 83, would you also look at noun 54 so we can check that one? Okay, verb 83.
What now? Okay.
Okay, now 54, 6.24 miles and 0 velocity.
Roger.
How's it look down there?
Looks fine.
Drive to a P-37, see what it looks like.
Roger. Apollo 12, for your information, at the end of the second quarter, Michigan leads Ohio State 21-12.
Okay. Startling, huh?
There's still a little more
Hey,
to go.
Don, ask
Go ahead.
Okay, ask FAO if he knows a secret hiding place for P-30 pads in the spacecraft.
We're not sure you're cleared for that information.
Well, I'd sure like to be because we ran out of 2 days ago.
He doesn't know of any other place, any special place to look. We'll ask around in the back room, but first quick guess is he doesn't know.
No, I don't think there are any. So we've been manufacturing them for 2 days.
Roger, we'll research it some more.
Okay, these guys didn't have anything to do anyhow.
We'll try to keep down the number of mid-courses so you won't need any more.
That's good, that's good.
At 195 hours 14 minutes, Apollo 12's distance from Earth is 167,578 nautical miles. Velocity 3,300 feet per second.
Dick, would you confirm that you terminated the water dump for us?
Oh, that's affirmative. We terminated when you hollered at us.
Fine, thank you.
Right. Doesn't it look like it?
Oh, we can't tell for several hours, and they were worried.
Okay, I'll check it again, but I know we did.
No sweat if you did it.
Rest assured, it's terminated.
Roger, thank you. Apollo 12, Houston, according to all our information down here, the only P-30 pads you have are in that CSM update book, and there should be only 12 of them, counting both sides of the page.
Yeah, okay, that's fine. We ran out. That's all right. We just thought maybe there was some more on here someplace else.
Not to our knowledge.
We've already scrounged a couple of P-30 pads out of some contingency books, so when they think of those, I forget passing it up because we already got them.
Roger. Dick, we rechecked your P-37 solution down here in our computers, and it agreed exactly.
Very good.
This is Apollo Control at 195 hours 48 minutes. Apollo 12 is 166,500 nautical miles from Earth, approaching at a velocity of 3,325 feet per second.
Here's Apollo 12.
12, go.
Don, if you think we're stable enough, if it looks like we're under control down there, we're going to go ahead and start PTC.
We suggest you let your rate stamp out a little bit more.
That's a suggestion I'll gladly follow.
Roger.
I guess the reason they're there, we're still moving around a bit. Everybody's cleaning up and shaving. We're through dumping water and everything else overboard, so we thought we could try and get it started. Maybe we better remain a little more calm inside here.
Roger. Apollo 12.
Hello?
Roger, the rates look okay to start up on PTC. We'd like you to turn off the high gain, turn the power off, and start with Omni Bravo as you start the PTC.
Okay, high gain power off and Omni Bravo for PTC.
That's affirmative.
And we're on Omni Bravo.
Thank you.
This is Apollo Control at 196 hours 18 minutes. Apollo 12's distance from Earth now 165,521 nautical miles. Velocity 3,347 feet per second.
Apollo 12, Houston. Apollo 12, Houston.
Go ahead, Houston, Apollo 12.
Roger, we suspect that after the evaporator temperatures stabilize here in your PTC maneuver, the temperature in the cabin may get a little warm for you. So we want you to evaluate what that feels like before you get ready to settle down for the night, and we may either have to adjust the mixing ratio colder or go back to auto at your choice.
Okay, last night it was fairly cold PTC in it, so I assume we're just going to, if it gets too warm this way, when we finally get in the proper attitude, I guess we'll just have to turn it down a smidgen.
Roger, it'll probably take about another
It's got to be
hour.
somewhere between what?
It'll take about another hour probably to stabilize.
Okay, okay.
Apollo 12, Houston.
Go.
Pete, sometime this evening, if you've got time, we've got some geology questions down here that we would like to send up to you. And when you want to discuss them, we'll pipe them up to you if that's all right with you.
Are these different from the geology questions we got about 3 or 4 hours ago? We're glad to do it.
That is affirmative. It's really a continuation of the same kind of material, but we've got 8 specific questions.
Okay, why don't we start in about 10 minutes. We're cleaning up from a meal and we'll be ready to go in 10 minutes.
Finery, any time is fine. Thank you.
Hello, Houston, Apollo 12.
Go 12.
Roger, we're ready for your questions.
Okay, let's start with 2 quick ones on the Surveyor work. The first one is, are you bringing back any glass from the Surveyor thermal switch plate?
No. The
the glass, apparently, which we didn't know, was bonded onto metal. And then the metal, in turn, was bonded onto the little standoff things that held it off the top of the box. And we tried to get it, and everybody had told us back there that it was going to have separated from its bonding, and it had not. It was in great shape. It was bonded to the metal just perfect. And we beat on it, smashed and bent. All we did was break it in little teeny tiny pieces. Shatter it, actually, is what happened, and it just remains fastened very tenaciously to the metal it was bonded to, and that was that. We just couldn't get it.
Roger, whoever made that bonding material will appreciate that testimonial. Okay, on the second one, did you get any soil sample from the Surveyor trenching area other than the material that may be with the scoop itself?
The scoop itself has some material left in it, I believe, or it'll be in that bag, and that'll be it.
Okay, Roger. Next question now goes to the geology area, and the questions, well, let's start out here. Did you ever climb one of those mounds, and what more description can you give us of the mounds, and particularly, was there any apparent orientation or elongation to the mounds? Also, anything about vent holes?
Okay, now the mounds weren't that big that you would climb one. You could just stand and look at it. There were two of them. One was bigger than the other. And no, they didn't have any vent holes. Their orientation, both of them appeared to be in a east-west direction. Sort of let's say you had a strip that was about a foot wide, and you just bent it and made a little triangular thing out of it. The mounds look something like that, and we sampled all around one mound, brought back stuff from it, material, Yule Clint, and that's about all I can say for them. They didn't have vent holes. I guess you're hunting around for anything of volcanic in nature, and they didn't appear to be, to us anyhow. So they appeared more like a big glob of something that had been pinched into that particular area, either by the craters that were formed nearby or something else from further away. And we looked around for all evidences of vent holes or anything coming out of it that might be scattered around, let's say rocks from it itself or some ejected pyroplastics around on the ground might be near it. We couldn't find any of those either. I was kind of wondering at the time why you did ask us to give a core tube through it, but you didn't.
Roger, thanks. Next, if there's no more on that one, the next one is whether or not you noticed any preferential distribution of the glass beads and the glassy material.
Generally speaking, it was all over the place in the bottom of even the smallest little craters that we came across. But we found it wherever we went, and no more in one place than another. I think that we have 3 or 4 samples of glass that look the same that were taken in different places, and they should be documented. One of them isn't, but I remember where we got it.
Roger, I'm not sure I understand. Did you mean that the glass beads were in the bottoms of all craters, or that they were on the tops of the level surface as well as in the bottoms of craters?
That's right. We walk around on the level surface. If you just looked around and looked even halfway, you'd find beads here and there. Now, you didn't find a lot of big ones. We run across big ones every once in a while, big ones being a quarter to 3/8 of an inch in size. We'd find those, we'd see them, but generally there were a lot of little ones around.
Now, if you look down in the small craters, I'm thinking of craters in 3 or 4 foot diameter, maybe a foot deep, that didn't look like they were made with very big objects, you'd usually find glass beads at the bottom, and you usually find glass-covered rocks. And that was surprising to us, because we'd always imagined that these beads just came from the larger craters up to 8 or 9 or 10 feet, but didn't seem to be the case.
Also, as I remember, we have a rock which is some 2 inches or so in size that is spattered with glass, and we brought it back for that reason. They're not beads, it's just a big...
Break, we've lost antenna for a moment. Apollo, break, we've lost Tom for a moment. Apollo 12, Houston, do you read us? Apollo 12, Houston, do you read?
Roger, we apparently lost your antenna for a while. We're ready to go again.
Roger, yeah, we switched antennas there. Al, the last thing we heard you saying was that in some of the small craters there were glass-covered rocks. Would you repeat anything after that?
Roger, did you hear Pete's description?
Negative.
Okay, right. I was saying that even in the craters up to as little as 3 or 4 feet in diameter, 1 foot deep, the ones that didn't look to me like they were made by either very heavy particles or very fast particles, you could usually look around at the bottom of them and see glass-covered small rocks, and a number of them. We took some pictures and documented them real well, and then I'll let Pete, well, let me say the rest. Also, one time when we were walking around outside a big crater, we saw a rock about 3 inches diameter, I guess, somewhere around in that neighborhood, and it was almost completely covered with this glass. And the glass looks the same as the glass you see in the close-up stereo pictures that Neil brought back, that he took pictures of down in small craters. So this will be a nice sample for somebody to work over.
Very good. Okay, next question is, can you give us some more detail on the material that appeared to be melted in the bottom of Bench Crater? Did this just cover the central peak, or did it appear more extensively located, spread around down there?
It appeared to me to look a little bit lava-like in nature, but I don't mean to imply that I thought the crater was volcanic in origin. It looked more to me like we were seeing the effects of some high-speed impact and causing some melting of material down there. I wish that we could have gone down in that crater and gotten a sample, but it was too steep and too rugged for us to attempt it. And therefore, we did take some partial pan stereo of the whole crater for you, and we tried to get material from the top, but nothing from the top resembled the material in the bottom. I think the reason Pete said that to begin with is our experience over in Hawaii in some of those chains of craters, or those lines of, I can't think of the exact word now, but where the lava comes out in long cracks, zones of weakness, it just sort of bubbles out and spatters one on top of itself. It ends up making sort of knobby-looking mounds of basalt. Well, from
on the top of the crater, all this stuff looked like knobby little mounds that were sort of like these things, like rift zones, with the material that you usually see around rift zones. And that's why he's trying to say that neither of us think it was a volcanic material, but it has that sort of melted, knobby effect. We got a lot of pictures of it, though.
Roger. On the northwest side of Head Crater, you talked about a rock that you kicked over, and you mentioned that the bottom was different from the top, and we're not sure just in what way it was different. Remember that one?
Well, yes, I remember it, and it wasn't different in, I think I should maybe have clarified it there, because it wasn't that big a deal. I guess it was the first time that when we kicked over a rock, it was two different colors, you know. Before you kick over a rock, and it looks just like the top is the bottom. This one, it looked a little bit lighter gray. And the reason was, after I thought about it, was because we were marching around in that same area where we noticed that there were two different kinds of soil. The soil that was the topsoil for just a thin layer on the top of 1/8 of an inch or something, and then below that was the thin gray layer. And what was causing the rock to appear white in this case instead of gray like the top was the fact that it had been in this light soil down beneath the surface. So I don't think it's a big thing.
Roger. Let me give you the last two questions so you can cover them together. The first one is, are there any special or unusual features that you remember thinking back on it now that you didn't have time to describe? And the other thing is, can you sort of recap the traverse along each leg and recall what you think was the significant features that you saw at each of the stations where you stopped?
Wait one while we discuss it a second.
Sure.
I think we pretty well talked about everything that we saw that attracted our attention. We can't think of anything right now that we saw that we did mention to you sometime or another, either during the EVAs or after. Al's only comment, which he already said he talked about this morning, was the fact that the color did change with the sun angle between the first day and the second day. As far as the traverse goes, I guess that the most significant thing, there was nothing unusual in Head Crater other than the fact that we found that I guess the Head Crater was where we first saw the difference in soil below the ground and above the ground. The next most significant thing, I think, is as we did go over to Sharp Crater, yeah. No, Head Crater is not where we saw. No. The crater, what was the name of the crater that we saw the material we just discussed? That was Bench Crater, right?
Say again on that, 12.
Wasn't the name of the crater, our second stop on the traverse was Bench Crater, is that correct?
That's right.
Okay. I'd get our books out, except they're so dirty with dust in them. We've had a heck of a time getting rid of the dust in the command module. I don't want to do that.
No, don't.
We discussed the difference in texture of the rocks at the bottom of that crater. I guess the next most significant thing was that somewhere between Bench Crater and Sharp Crater, we obviously ran over what must be a contact, and that the ground very definitely changed to a softer, finer dust. We sank in deeper
out there, not only right at Sharp Crater, but leading up to it. Now, we both found it very difficult to ever walk slowly. We always went at a lope wherever we went. That just seemed the natural way to go. And so Al sort of spotted it first watching me run because he was behind, and he could tell that I guess I was kicking up more dust. Is that right, Al?
That's right. It was obvious that Peter started running on different kind of ground. Back in his V1, it turned out it was different kind of ground.
And I guess that's the most significant thing over there on that part of the traverse. From there, we're not sure that we ever did get to Halo Crater. There turned out, now I'm going to have to look at our photographs, and I'm going to have to look at the maps again and figure out exactly where Halo Crater was, because there were about 5 little craters, all of them which could have been Halo Crater all together, and it wasn't apparent in looking at the little map that we had, which was colored at that spot, whether there were 5 craters or 2 craters or what, and I had a very difficult time locating it. We suspected we were not at Halo Crater, but if we weren't, we were awful darn close to it. I guess the next significant thing was the fact that from Halo Crater, or coming up to Halo Crater, we really got on a third type ground, which was the ground that we discussed around the Surveyor crater, which seemed to be the firmest, especially down in the crater. It seemed to be the most firm ground that we were on. It still had dust. We still sank in, but we sank in the least in the Surveyor crater, both going down to the Surveyor from the one side and going up towards the Lemp through that blocky crater on the other side nearest the Lemp. The blocky crater was also an interesting feature, and that may be something that I think we did discuss, though, as we stood there, was the fact that we felt that the Surveyor crater was an old crater that had been impacted and was made... Go ahead.
Hold on for just a second. We're going to have to switch antennas, and we may lose you for a second.
Okay.
Apollo 12, Houston, we got a good signal. Go ahead.
Okay, I guess we discussed that we felt the Surveyor crater must have been impacted very early and had bedrock, and that this bedrock had weathered down to where the crater was very smooth, and there wasn't much there, and then along came another one and made this small blocky crater in the side of it, which must have been which indicated to me that bedrock was not too far below the surface, right where we were at the Surveyor crater. And of course we have samples of that. Something that Al and I just were talking about, he wanted me to mention that the Surveyor, except for the fact that it had changed color, looked in very good shape. This is true, but there's something that I noticed using the cutters. Supposedly, the tubes that we used in practice were exactly the same metal and aluminum that the Surveyor was made out of. And if this is the case, something very definitely happened to the metal, like it crystallized, because it was much easier to cut the Surveyor tubes, except the one tube which I flat couldn't cut, and I think that they were off on their dimension on that tube. It must have been a much stronger tube than they'd indicated. Much thicker tube, thicker wall tube. But the wire bundles that we cut too also had the appearance of being very brittle. They cut very, very easily. The coating flaked off insulation. And there was one wire bundle that had a cloth insulation on it, which was not on our mock-up. And there was the other wire bundle, which was on the mock-up, wasn't quite the configuration that it was in the mock-up. But these wire bundles seem to cut quite easily also. And I don't think it's because I was juiced up. I think there was very definite crystallization or something there in the metals. You'll get to see that with the stuff we bring back.
Very good.
I guess the last most significant thing is that Al and I and Dick also, having watched our training, were impressed with the fact that we managed to get as far around as we did, and that it was as easy going in that kind of country as it turned out to be. The distance that we covered, I guess we covered a little over a mile. You could, on Earth, in your equipment, if you had lunar weight equipment on Earth, you could never make that traverse in that time. You'd die before you got to the end, and we weren't even sweating. We were just kind of hopping around out there doing the job. The only thing that kept us from moving faster was there was so much to see. Also, the only thing that kept us from studying more details at each site was the fact that we had to keep pressing on. So what's going to happen when we get back? We're not going to know all the details of each site because we just weren't able to stay there long enough, as long as we'd like to at any site. We could have spent that whole time at any of those craters, trenched around them, and looked at and collected different size type rocks around it, and tried to go back and forth on the ejecta blanket, see if we could discover any difference in texture and all that sort of thing. But the time just wasn't available. It was one of those things of how much you want to cover and the time you got to do it. You know, what Al's saying is we did Big Bend, Hawaii, Meteor Crater, and New Mexico, all in 1 2-hour trip around there. That's about what it amounted to.
Yeah, you did a great job on it, too. Hey, listen, when you looked into the craters, did you notice any boulder tracks that indicated there had been many rocks rolled down, besides the ones you rolled down, or accumulations of boulders at the bottom of these steep slopes?
No, not any particular distribution. When there were rocks at the bottom, it was in these blocky craters where it looked like the material had been there.
Right.
Now, the dust is such, and I'm sorry, I just didn't observe. It wasn't really standing in a position to observe any track that the one rock made that I rolled down. The other rock that I threw down there was so small that it didn't go very far anyhow. And now dust flew, and the rocks both bounded and rolled, depending on how far along it was going down the side of the crater. But it was not obvious to me that it was making any track. Now, had you stood back and looked at it from a different sun angle, I feel that maybe it would for a while, just like it was very obvious when we looked out our window where we had been walking around. We could see for great distances where our footsteps went.
Yeah, the seismologists are trying to get some feeling for whether or not you thought there was a lot of rock rolling that might be causing the signals that they see.
Well, if there was, it was not evident to us. Most of the rocks that we saw on the side of craters all had dust around the bottom of them, and it didn't look like they'd moved for a long, long period of time, and most of them looked like they were partially buried. The majority of them looked that way. That's right. Not only that, we didn't see any look like they thought they were going to roll down in the near future either.
Roger. Hey, listen, when you pulled out the core tube, did the holes collapse, or did they stay there?
That's a good question. We didn't really look down it, did we? Yeah. I did say that right. I was talking to Pete. The tubes themselves stayed pretty doggone uncollapsed, except for the top 1 or 2 inches. The minute you draw out the core tube, that top 1 inch, let's say, not 2, 1 inch or so, would kind of crumble off, and some parts would fall down in. But the sides were still relatively vertical. It's the same thing that happened in the trenches. When Pete
everything would dig the trenches. The sides would be almost 90 degrees, except every time he tapped the side, let's say accidentally with his shovel, then that part would get knocked off. But the part that would remain would still remain 90 degrees. As long as you didn't touch it, it seemed to be happy right there at 90 degrees. Yeah, and then that reminds me of another thing. That pulsed my memory. Again, this is an impression. It seemed to me that there were angles greater than 90 degrees in the trenches, implying layering. And although there wasn't any difference in color, it seems to me that would sort of imply that there was some layering there, and that maybe this material is built up over a different time frame. If that's really true, you'll see that in the photographs.
Very good. Hey, listen, when you deployed the solar wind experiment, did that staff go down into the ground far enough to let the bottom of the foil contact the surface? And when you rolled it back up, did all of the foil have difficulty in rolling up, or is some of the top section of that rolled up smoothly? Do you remember?
Yeah, the answer to the first question is, it didn't go all the way down until it touched the soil. It would have, I think, if we could have pushed on. I pushed on it as hard as I could, and then I kind of pushed on it hard enough to lift my feet off the ground, and it went down that far, which was a foot or so. I can't recall, but I did take a picture of it. You'll be able to easily determine how far it went. That was all the force I could put on it. The answer to the second question is, when it started to roll up, it rolled up about a foot and a half, and then it didn't want to roll up anymore. It wanted to crinkle. It just didn't want to roll. Okay, so I pulled it down and rolled it up, pulled it down and rolled it up. And about the fifth roll up, that crinkle area tore in a longitudinal crack. It just all of a sudden cracked. And I said, uh-oh, things are going to get a little difficult here. So I stretched it out again. I was pretty tender with it all the time. I wasn't being clumsy about it because I had some experience with these foils under vacuum conditions in the chamber that they get awful tender. And all the time I was being as careful as I could. So I started to roll it back up again, and it started to tear some more. So I realized at that time that it was not going to roll up. So what I did was let it go, and let the roller go. It swung around a couple times. And then what I tried to do is and I took the roller off the staff and held on the roller, and then I tried to hold one end, hold the roller, and just roll it up using the side.
Apollo 12, we're switching antennas again. Apollo 12, Houston.
Go ahead.
Yeah, we lost you on another antenna switchover. Al, you were just saying that you held one end of the roller and were rolling the foil back up when we lost you.
Okay, then I rolled it up as best I could with my fingers on the edge, realizing that I was going to get some lunar dirt in it, but there wasn't any other way to solve the problem. And I tried to be clean with it, but I'm sure there's going to be some dirt on it, and I hope we can, you know, the experimenters can brush the dirt off or bake it off or do whatever they bake out the molecules, so maybe they can just dust it off, and, you know, dust the thing off, and hopefully there won't be any waste. Now, when they find it, when I finally took it back to the rock box to put in his Teflon bag, we looked at the bag and we looked at the roller, and by my technique of rolling it, the roller was bigger than the bag. So I took my hands and just crushed the foil on the outside, you know, just squeezed it together, made it big and small enough to fit in the bag we put in. So that outside layer has got a lot of dirt for my hands on it, but inside it ought to be relatively clean, particularly on the side nearest the hinge point, because I tried to never touch there.
Roger, that sounds good, Al. I'm sure the data's still good on it, and they just wanted to plan their procedures in the LRL. Listen, that's all the questions we had for you, unless there are some other things that come to mind.
Okay, let me throw one at you so I don't forget it.
Okay.
You know, we had some trouble with those Teflon bags. We had some trouble with those Teflon bags overnight on the lunar surface. They cracked. It just didn't act right. Pete reported it, I'm sure it's documented. I got to thinking, maybe that's what happened to that aluminum foil roll. The tape that holds the foil together and everything else, I don't know what it is. But if it's Teflon tape, something like it, maybe that's what's giving us our problem. It just doesn't want to roll up after a certain period of time, exposed to either vacuum or cold or something else. I know it just doesn't work like it does when we're training in the atmosphere with a new roll.
Roger. Hey, listen, they've just handed me two more questions.
And one.
Go ahead.
Let me say one other thing about that also confirms I hadn't thought about it either. Remember the first day we was just hanging out there like an old window shade. Okay, remember when we got up the second morning, we looked out there and I called back and said, look, Pete and I both think that this thing has been wrapped around the pole. Because when I got out there it hadn't been, but it had taken a definite set. The metal wasn't flat as it had been before, like a window shade. It sort of had a candy corner set in it with not a crease, but sort of a hill running candy corner across it about half the height of the diameter of the staff. And so maybe that aluminum foil under vacuum or whatever the tape is takes the set, and it just doesn't want to roll up because the set is stronger than the spring tension.
That certainly could be. Hey, listen, did you take any close-up stereo pictures outside of the disturbed area, and if so, where?
We took close-up. Oh, I know what you mean. You mean close-up stereo camera?
That's right.
Yes, we did. I took some near the engine, as I talked about. Then I walked out and took some in the bottom of some little craters that we had not walked in. Then I took some of Pete's footsteps, 3 or 4 of those. Then I went out into a couple of areas that we hadn't been and took some photographs. But we were not able, because of the time, to really do as many pictures as we wanted and do as many different things. And that's just one of that. Since that was the last experiment, that's one that just sort of suffered. And so we'll just have to see what we get out of that one. I wasn't particularly satisfied with the way it was at the end, but we'll just have to see what happens.
Roger. Listen, that's all our questions. Let me mention a couple of things that I think you'll find interesting. You were concerned about the dust on the ALSEP experiments. The heat-up thermal curves are going just exactly along the predicted lines. So apparently you guys did just a great job on working in those dusty conditions, because there appear to be no thermal problems on that thing. And I guess you've already heard some of the results on the passive seismic when you sent down the lunar module. The whole Maria, or at least that area, vibrated like a plate for some 35 minutes. And the scientists are really delighted in the kind of data they're getting out of that. They haven't figured out what it means yet, but they're sure interested in the data.
Say, we've been wondering something up here. Did you happen to figure out why the limb impacted as far from the seismic experiment as it did?
Yeah, we had to turn that off from the ground, and there was a slight overburn in getting the signals up there to turn off the computer. And the slight overburn dropped it in a little further east than we had programmed.
trying to strike that out up here. Okay, thank you.
Listen, we got a couple of final scores for you. Michigan 24 and Ohio State 12. Missouri 69, Kansas 21.
Sounds good. How about giving our families a call in the next 10 minutes and see what's going on?
Roger, I tried a few minutes ago, and your
I
wife...
guess it's fine.
Couldn't catch your wives home a few minutes ago. I'll give them a try again. Thanks.
Okay, thanks, Don.
There's a luncheon going on over in your neighborhood someplace.
Oh, that's right.
At 197 hours 23 minutes, Apollo 12's distance from Earth is 163,401 nautical miles. Velocity 3,396 feet per second.
Apollo 12, Houston.
Go ahead, Houston.
Roger, I just talked to your ladies. Pete, Jane said that Christopher got a bike for his birthday, and within an hour after he got it, it had a small accident. He didn't have any problems, but the bike is a little worse for wear. He's a little disturbed over that. Also, Peter went with the Allens up to Elkins Lake deer hunting. They're supposed to be back tomorrow afternoon, so of course now we have no report on his prowess as a hunter. And she was particularly delighted with the way the flight's going. She says to really congratulate you on a good flight, and they're looking for you back home.
Thank you, Don.
Dick, talk to Mark.
Dick's not up right now. I talked to Al.
Okay, Al. Talk to Sue. She went...
Oh, wait a minute. He's not out. Don. Al's not on it either. Wait a second. I got to get him up on the comm. We're just chlorinating water and doing a few things here.
Roger.
I'll give you a call in a minute.
Fine.
Go ahead, Don.
Roger. Dick, I talked to Barbara.
No, this is Al.
Oh, okay. Let's hold off on this. We're about to switch antennas. I'll be back with you in a minute. Apollo 12, Houston. Okay, Al, Sue reports that they had a real nice luncheon. She went to that this afternoon. The kids, of course, are home from school, and today's a real nice day here in Houston, so they've been having fun around the house. And the only other thing is that they're really getting anxious for Monday and get you guys back down here on the Earth.
Thank you, Don. We feel the same way, believe me.
Roger. Is Dick around there yet?
And Dick's up.
Okay, Barbara...
He's up. Go ahead.
Roger. Barbara reports that Uncle Herb has repaired all the bicycles, and so the kids are really delighted with that. She also reported that the luncheon went off very nicely. Also, Mom and Dad have gone up with Aunt Mary to restock the larders around the house to get all the food they need in the house. Barbara reports the children have been particularly good today, and she's very happy over that, obviously, and that they're happy about the flight and really looking forward to splashdown.
Well, sounds like a normal day around the Gordon household. Thank you, Don.
Roger. Listen, we got some final ball scores for you. Cornell 28 over Penn 14. Penn State over Pittsburgh 27-7. Pete, Princeton took Dartmouth 35-7. Purdue 44, Indiana 21. Notre Dame took Air Force 13-6. And a third quarter score, Tennessee 24 and Kentucky 14.
Very good. Let me give you the pre-sleep checklist. The crew status report is as follows. CDR had 1, decongestant. CMP had 1, and Al had a sleeping pill last night. That's about that. We've cycled the fans, chlorinated the water. The valves are all in the proper position. You got the E-memory dump, and the BAT C is 37.0, Pyrobat A 37.0, Pyrobat B is 37.0. And we're on main A on the DC indicator. And that's about it.
Very good. Hey, listen, a preliminary report on the antenna test shows that the problem is associated with heating. We want to run another test tomorrow in which we hope to pin down exactly which component of the electronics is experiencing that heating. We'll brief you on this in the morning, but it won't involve much for the crew, mostly just orienting the thing and letting it heat up and making a couple of switch changes. But this probably means that we may slide the second P23 back about an hour, but we'll brief you on that change and what the test consists of first thing in the morning.
Okay, and I guess the other question is, do they still plan to do the TV the way we talked about it before the flight?
Stand by a second.
No, we don't need the answer to it right now. It's just between now and tomorrow sometime.
Pete, the plans are to go ahead as briefed before the flight.
Okay, very good.
You guys got anything else for us before you go Betty bye?
Don't think so.
Well, have a pleasant night's sleep, and we'll see you in the morning then.
Only thing that's in short supply up here right now is tape recorder batteries. We're on max conserve on that right now, so we can squeeze the last drop of music out of her. Right. Tell the skipper of that ship to put it right on the center of the target, because Dick Gordon's going to be driving it right to that point.
Very good. Hey, listen, if you run out of tape music, have Pete give you some of that dum-de-dum-dum stuff.
You mean Tiki Boo and all that jazz?
That's right. Apollo 12, Houston. The surgeon was wondering if anybody was going to be hooked up on bio harness tonight.
We'd prefer not to. I don't have any on, and the other two guys, it just is a pain in the neck getting in the bag with all that big cable hooked up. Anyway, you don't need it for anything, do you? Hey, I'll tell you, let me ask this question. How about letting us, all of us, just completely unplug and not even get on the radio? And if you want us for anything, use the crew alert, and we'll have the amplifier on the master alarm. It works fine. What do you think about that?
That's fine with us.
Very good.
The surgeon will sleep as well as you do with no biomed to watch.
That's great. That's good. He may be interested in the fact that we're taking these decongestants, but this spacecraft is so loaded with dust, I can't believe it. We got to clean the screens about every 2 hours. What we brought back from the LEM must have been the world's record for dust. And we've just been having one whale of a time getting this thing clean. I thought it'd be clean in a matter of 8 to 12 hours, but we've been cleaning screens about 2-3 hours apart since we came back from the lunar surface, and we're still getting junk off them.
Roger, all the medical types down
much
here.
More so than going out.
The surgeons down here are reviewing their treatment for silicosis, so we'll be prepared for you.
What in heaven's name is that?
It's a miner's disease from breathing coal dust.
There you go, okay, I'm with you.
Hey, we're going to send up a crew alarm here for you in just a second, just a crew alert, excuse me, to check out the system.
Okay, when we get the power on the, we're just rigging the phone now. Plug in, ready to go.
Tell us when you're ready.
We're ready. Works just fine, you hear it?
Yeah, we heard it down here. Finally, we'll rest in comfort.
Okay, so will we. Nighty-night.
Nighty-night.
Hey, God, tell Paul Weiss to have a lively night tonight, will you?
Will do.
This is Apollo Control at 197 hours 46 minutes. We said good night to the crew at 197 hours 45 minutes elapsed time. Apollo 12 is 162,665 nautical miles from Earth, approaching at a velocity of 3,413 feet per second. As you heard, we will not monitor crew heart rates or respiration this evening. And the crew has also disconnected their communication system. And if we need to arouse them, we'll use the crew alert system, which you heard tested. At 197 hours 47 minutes, this is Mission Control, Houston. This is Apollo Control at 198 hours 18 minutes. We've had no further conversation with the crew since saying good night to them at 197 hours 45 minutes. At present, Apollo 12 is 161,607 nautical miles from Earth. Spacecraft velocity 3,438 feet per second. The entry clock has been started here in the Mission Control Center. It shows we're 46 hours 2 minutes away from entry interface. That's from the time the spacecraft reaches 400,000 feet. At 198 hours 18 minutes, this is Mission Control, Houston. This is Apollo Control at 199 hours 18 minutes. We've had no conversation with the crew since the rest period started at 197 hours 45 minutes. Monitoring spacecraft systems by telemetry, all systems functioning normally. Apollo 12 continues to get closer to the Earth. Distance now 159,689 nautical miles. Velocity 3,485 feet per second. This is Mission Control Houston at 199 hours, 18 minutes.